It's okay now. It's very audible.
Okay, great. Let me start presenting. Okay, great. So I was saying that. So I don't know if I was unable. I was, I was not able to be heard. So what I was saying is like instead of having to do the DAX, I have prepared a small PPT. We can go through the PPT as we do the DAX. It has some tasks, and then we stick to those tasks. I think that would be quite easier, and that will also save a lot of time than having to actually try go about try and error. So trial and error. Yeah, so let me share my screen. So this is a small PPT that I've actually prepared. I can share this. We can go through the initial definition and those kind of things before we actually start loading the data. Yeah, so first thing first, so we need to actually understand what DAX is. So it's from what you can see in your screens, on your screens, you can see this is like two simple DAX expressions. We have a min-x, we have customers, we have total sales in square bracket, and then we have and then we have a sum, wine sales, cases sold. So by looking at these two actual expressions, someone can easily tell you like this one is a simple and DAX tax, or maybe DAX simple DAX syntax, and then someone else can tell you this one also stands for something. So for instance, if I go through this, it has a function that it says min-x, and then we have a customers, which is a table, and then I have a square bracket that says actually total sales. So if someone can tell you this is a column, I can say this is a measure. I have a reason I'm saying this could be a measure, not a column. Then when someone comes to here and they see sum, then we have the wine sales, cases sold. This one, so I can easily tell you this one means probably a normal when we're calling for objects, and we are referencing objects. We are referencing the object is table, and then the other object we are referencing is the column. I'll come and explain more about this because there's a lot of things we need to understand. But for us to actually know, it's simple to just the syntax of each DAX function. But what is more important is understanding how these calculations, the expressions perform calculations. So calculations actually are performed by these expressions based on these important concepts you have written. So we have the raw context, we have the filter context, we have the iterators, and then we have the context transition. So using if we understand these four concepts, then it will be easy for us to actually come up with any DAX calculations and any DAX formulas. So I hope we'll be able to cover all of them. But what's more important is if we cover the first three, and we have, because most of these DAX expressions fall under these three. So once we have that, then we can move on. So if we move to the next slide, we have a types. If they categorize into the output or into the values they actually return, we can say DAX functions. The first one is the scalar function, that's the DAX type. So the scalar function normally returns scalar value, and this is the function, and makes calculate all X aggregators as well. So then the second function type we can categorize is the table functions. The table functions normally generate virtual tables. So all this, seeing these values, we will explain very well, and we will know how and when we need to use these table functions. And table functions normally they actually propagate filters through data model in the same way that field tables propagate. We'll also explain what this terms propagation of filters means. Example of these functions are filter, values, previous month, and all function. The third step of DAX is the actual return filter argument. So we took the expression as the filter, so must be the argument of calculate. Example is crossover, user relationship, keep filters, and all. So we have all in both these two tables. We have both these two function types. We have the table function and the calculate modifiers. So all is a kind of all function all expression is very interesting. We will hopefully we'll have the time to look at this because it can act as a filter at the same time. It can act as a filter, sorry, it can act as it can create virtual tables by creating tables, act as a function, table functions. At the same time, it can create filters. So using both calculate modifiers and also table functions. Great. So up to that point, if there's no any question, we can actually begin to have a look at our data. So we can load the data, and then we'll discuss the importance of having a structured data. All right. Nehemiah, if I'm not audible, please just stop me and actually tell me that I've lost my connection because I can't see there.
All right, I will.
Okay. Okay, let's write that here. So one thing that is very important all the time is that whenever we are considering the details of our expressions, they are always inextricably tied to the structure and the shape of our data set, so our data model. So it's very important that whenever we are doing a DAX expressions, before we move to any stage, we have a very clear way of actually having our data. So in this session, we're not discussing anything else. We're not discussing visuals. We're not on this data. So this is already normalized. And so you can have one big an Excel document that has all these columns. Now it's up to you to actually normalize this data. So we will briefly touch maybe on the denormalization and importance when we're doing DAX, but not really. We're not going to actually do any normalization here. But we'll just maybe go through this data and see what it entails. So I think yesterday we've discussed the normalizing data in actually Excels using pivot tables. So the process is more like you can use the Power Query, you have to do the normalization. But I've done this one externally because I was actually thinking going through each of these tables separately. So we have 1, 2, 3, 4, 5, 6 tables here. So if we start with the wine cells, this table contains cells actually transactions. So this data basically it contains it's a data that contains a wines being sold. So let's say, for instance, the best experience is when you get wines, but is a business that actually sells wines, and we have the first table as wine sales. This table contains the sales transaction. So which actually I think here we have the order date. So we have the sale date. Has the wine sale number, the salesperson, the person who sold, and we have also the customer ID, we have the wine ID, and then we have the pieces sold. So we don't have any costs here, but we later on create those kind of things. But right now we don't. And then if we go to the wines, this actually is another table that contains the type of the kind of the wine actually, and its description. So this. And then we have regions selling this wine to probably are actually within these regions from Argentina to Ireland, so these regions. Then if we go to the data table, the data table contains dates. That dates where actually the sales have started. So we have date key. These are actually the dates where sales have been made, right from the beginning up to the last financial year. For instance, if we are the to December 2021. So basically this contains the data key. I don't need to actually go deep in depth, it's just people can easily understand. So it's categorized into year, quarter, year, and also month and month number and month. So these are basic things to understand. And then we have also customers, and these are the people actually. This table contains the people we are actually making sales to. Okay, so that's the most important thing. One thing we also we after looking at the tables, we find the tables are fine. We have different tables, and then the second thing to check is actually the relationships, and also how these actually tables are related. Just zoom out and see. It looks mess. All right. So before we actually do DAX expression, DAX calculations, the first thing to do is actually look at the structure of your data, because whatever you're doing in DAX actually is just what's happening here. So if you could see something you don't see that actually DAX engine does, but they're very simple to understand, although not all the simplest, but whatever we're doing there, it's just basically what is actually we're seeing here. So anything you are doing with the DAX, the more your data is unstructured, the more you need to actually do more or author more complex data, DAX and expressions. So the first thing is maybe arrange this one in a way that you think it's easier to understand for you. However way, but we'll come very soon and discuss about the schema and also the star schema in a way that shows the perfect way of actually organizing data. So the star schema basically is it says that you make sure that you create a direct relationship for different tables. So here we have tables. So these tables we have a wine cell tables, and then we have cells, all these. So the names given to these tables, we have the fact tables and we have the dimensions. And what do they stand for? So the fact tables are actually tables that actually answer the questions like what are you looking to analyze? And then we have the dimensions tables that actually try to answer the questions like how are you going to do the analysis? So it's important to actually differentiate these tables. So if you look at these tables, they're related. Mostly they're related. So you can see the customer tables, the dimensions. So you can just, I'll use dimensions instead of using customer tables most of the times. So the dimensions, for example, customer dimension here is related to wine cells. Sell people dimension is also related to wine cells. And wines dimension is also related to wine cells. Another thing here, we say that our date table contains date key, and those date key were the dates that actually we made cells. So there has to be a relationship between this dimension table, which is the date key, and the fact table, which is the wine cells. So creating this actually relationship is something I think everybody understands. We've done that. So we create using the managed relationship tool here. Then we start create a new one. Yeah, so the key thing here is just understanding your data. That's the most important thing, because you could do everything. You can do a lot of things, but if you don't understand what you're doing, it wouldn't make sense. So we were trying to actually create a relationship for, let's say, a date table and wine cells. Or you think probably this is something that you have not gotten what I'm going too fast, just stop me and ask me. And that's why we're here, we're discussing, so that you can benefit. You might be raising something that I'm not seeing, or you might have a different opinion than how I'm doing things. Probably will also helpful for me to also learn about things from you. So it will be good to have a session that is quite interactive with everybody. All right. So this is actually, I've actually created a relationship. So cross filter direction. So this thing we will discuss in depth later on, how to actually work with this. But now, what I would love is, like we always just avoid the by direction. Just leave it to that symbol. Okay. And whenever you're creating these relationships, one way of knowing that a table represents a fact table is that does that table contain a data that you're trying to analyze? If this table contains any data that you're trying to analyze, then that's a fact table for us. if I remove this table, for instance, the fact table, will the relationship between other dimension tables remain or other tables remain? That's how we can identify. So if I, for instance, remove this wine cells, and I've given, so let's say I've been given a data and I've opened the actually model here. I'm trying to see which one is actually my fact table and which one is not. So by looking at it, I can actually try to remove one of these tables. If I remove one of these tables, I see if other relationships are affected. For instance, if I remove customers, I delete this table, I'm pretty sure this one and this one and this one will not be affected. They'll remain because I've just removed this. Yes, but if I remove this, there won't be a relationship between these other tables. So the outcome is one way that gives you to understand about your fact table. And the other thing, the fact table contains all these many rows as compared to other tables, and it's constantly being updated to differentiate the fact table from the dimensions. And one thing that is very important, I've just mentioned, is the way I'm actually trying to differentiate between the dimensions and also the fact table is that because this find that the fact tables normally they allow for summarization, and the dimension tables they allow for filtering and grouping. So that's why sometimes we later on see we'll see later on that for measures they normally summarize. They normally take or maybe aggregate values of the fact table that is actually been grouped and filtered from the dimensions table. We'll see how that they look like. So let me try and edit this in a way that I actually think will make more sense. And let me just move these lines here, and then I move these cells here. So it doesn't make any difference the way you actually arrange. I'm just trying to come up with a way that actually I can say this looks beautiful. All right, great. So anyway, this is what we're talking about, the star schema. A star schema is when you have your data that your dimensions table are directly related to your fact table. So we obtained the fact that wine cells is our fact table. So we can see that these four dimensions tables, these four dimensions actually have direct relationship with the wine cells fact table. But we have regions that does not have a direct relationship with this, but it has a relationship with the wine cell through the customers. Together through the customers. So if you click on this arrow, you see that these two tables are actually connected by a column, and that column is called region ID. So these columns are the ones that create the relationship. Basically, I think everyone understands what I'm talking about. So what actually DAX tries to actually do is they tries to avoid ambiguity all the time. So what happens, for instance, if I actually create another dimensions table and I connect, so if one dimension table is connected to two other dimension tables, what happens? What does DAX do? So let's try and find out what actually DAX tries and do to avoid it, because for any filter to be propagated through to the wine cells, it has to actually it has to have a direct relationship with the fact table. And for instance, if I have another, let me create another. Let me connect this, for example, salespeople dimensions, regions and customers. All right. So when I do this, with an ambiguity, and we'll see how DAX deals with that ambiguity. So let's try to manage a relationship, and I create a new relationship, and I want to connect those three. So let me see. So for me, the best way to do that will be, I'm talking about salespeople, isn't it? Yeah, salespeople and customers. So let's try and do that and confirm that before I create that relationship. We have salespeople. I want to relate this sales dimension to regions and customers. Perfect. So we have salespeople and let's say regions, for instance, because I don't have this is an assumption. I'm just trying to create a hypothetical situation. How DAX deals with this kind of ambiguity situations where a filter can propagate to more than one, actually, can use to more than one path. So for instance, ID in the cells, in this cells people table, and I would connect that to this region ID. I leave this to be a single and the relationship to be H1, let's see. And I create that relationship. What happens? How does that feel with that? Let's see. Okay, so if we look at this, it creates a relationship that has a dotted line, which is actually normally said is an inactive. This is inactive. So if I want to actually propagate filter, if I want to, let's say, for instance, I want to see how regions connected to wine cells, it can either come through customers or it can either come through salespeople. So there's an ambiguity. So what DAX does is it makes this one to be inactive. So it has made inactive. We just actually took a random. So this is how DAX deals with ambiguity. So ambiguity is a factor. So sometimes there are, if you go to advanced DAX, you'll realize that there's a way you can bypass and create virtual relationships. This is virtual relationship. So yeah, so that's what I was actually trying to explain. And let me just get rid of that relationship itself. That's how DAX deals with, and it's very crucial for us to also have an understanding of what's happening behind the hood, as we normally call it. Yeah. All right. So at least we have discussed about the dimensions, we have discussed about the fact tables, and I think everyone has a bit of an idea of what that one is. So what do we call this region? For instance, this region table is actually coming to the customer. It's directed to the wines, as we say that. So sometimes we can call this as snowflake dimensions, and its parent dimension table, and then sometimes, yeah, we will later on see, maybe hopefully we're time. Sometimes if we are trying to control a filter, we might be required to actually, especially if we're using, for example, calculate distinct, those kind of expressions, we wouldn't be able to use a indirect relationship. For instance, if this one regions is indirectly related to the wine cells fact table, it won't work. So what we'll have to do is and then we actually create somehow we play around with that. Then we create a direct relationship with because if you integrate into the parent table, which is the customs here, then we will have a direct relationship with the fact table. In that process, we call it normalization, which hopefully we get the time to touch on that as well. For now, we can proceed. Any question up to that point? All right, fine. Let's move to the next step. At least we are going a bit faster. I thought we would delay in that, but we've actually moved a bit fast. So let's talk about calculated columns and measures. Calculated columns and measures is something I think everybody understands, but there's a trick part that we have to understand what they use, what actually calculated columns use in terms of, for instance, we just talked about the raw context, filter context, iterators. What do they use? When we understand those nitty-gritty details, then we'll implement and measure. So for calculated columns, they're typically evaluated for every row in the table and therefore can be process heavy. So this is a term that is just said, but we need to actually get into that. So we asked for a task here. So it's a task. We need to add a column in the wine sales table that's populated with either team A or team B. This column will group our sales people as follows. Sales people with ID 1, 3, and 6 are in team A. And I don't even focus about what the DAX will look like here. The only thing we just need to understand is how to calculate the table, the column, sorry, in that wines table. Once we do the calculation, then we see what it does and how we can justify for that process heavy. We'll also others. I'll also try to link, so to save time, I'll try to link our other functions when I'm talking about this. So in this case, for us to do that, it says here, we create a column in the wine sales table that's populated with either team A or team B. This column will group our salespeople as follows: salespeople with IDs 1, 3, and other sales. So this seems like we need to use a logical operator. So let's try and create that column. So the first thing we do is we click on the wine sales, then we have the table tools that appears, and we can also have a view on what's happening here. That could be easier. Then we actually create a new column. So here I don't want us to focus on how the DAX looks like. We just want to see what we are doing. Okay. So let's call this actually column as team, so it populates data on team A and team B, and then we have conditions here. So it looks like this is a logical condition. It's just a condition says that those salespeople with IDs 1, 3, and 6 will be grouped in A, and the rest will be grouped in B. So this seems like a condition. So let's equal. So let's use if.
Abdikadir.
Don't.
I think your network is breaking. Can you try to log in perhaps with your phone? Maybe your microphone, the phone microphone, will be stable. Because it seems like
okay.
You are breaking.
Is the video okay?
That's not that serious, but it has some bits of breaking.
Okay. Let me try and join with the phone.
Okay.
Is the screen okay? You're able to see?
Yeah, the screen is fine. The screen is fine.
Okay, fine.
You can mute also the speaker, the PC speaker, so that can avoid the echo. And then you try to talk, we see the feedback.
Right, how is it now?
Continue talking, but
Am I audible now, Nehemiah?
yeah, this one is very, very clear.
All right, great. Yeah. Thank you for that. So we said the focus is not about the if function. We will get later on deeply, but just to create the column right now, just make sure that you understand we're creating a column. So we have wine sales and the case is solved. Is that the case, or the question was like asking the salespeople ID in the wine sales table? Okay, so we have the salespeople with IDs 1, 3, and 6. So wine sales, have salespeople ID, maybe it's equal to 1. Wine sales argument, wine sales is equals to wine sales salesperson ID equals to 3. Wine salesperson ID equals to 6. right? So if that's the case, we want it to be team A and team B. Am I forgetting this all the time? So I want it to be okay. I'm having an issue. Yeah. Okay.
Are you talking? I can't hear you.
Are you able to hear me now?
Yes, I can. Okay.
Okay, great. So yeah, what we're trying to do. So we said we're adding a column in the wine cells table that populates either team A or team B. The column will be grouped. We'll group our cells as follows. So we have the cells people with ID 1, 3, and 6 in team A, and the other cells people in team B. Okay. Anyone who has an idea where we're getting this error? All right. Hello.
Hello.
Are you able to see my screen? Because I can't see from my phone. It's like I'm having it says like there's a network issue, I think. Yeah, it's logged off.
You've left.
A bit, yeah. My phone is fine. I don't know why this is saying is actually it's like leaving and it's saying it's leaving from the laptop. I don't know why. Let me try and reload again.
Okay.
Okay, I'm sorry about that. I'm actually having a very bad unstable network. Am I audible, Nehemiah, right now?
Yes, you are.
Okay, great. So let's continue. So the question was asking add column in the wine cells. Add column in the wine cells table that's actually that's populated with either team A or team B. This column will group our cells people as follows. So we have the cells people with IDs 1, 3, and 6. and the rest. So this is a logical this is a logical operator. So we have to use OR in between these ones. Okay. So we have OR that. Then we also have done just we'll actually get back into these things later on, and we will actually make sure we dissect into this very well. Right now, this part is actually to create a table column. Okay, so we have team A, and then otherwise it populates team B, right? Okay. Right. So
So when you use two vertical lines stand for OR.
Yeah, that's actually it's called the double pipe.
Oh, yeah.
The double pipe stands for OR, yes. So in this case, we're using a OR logical operator. So if, for instance, we have a wine salesperson ID is 1 or 3 or 6, then it will actually populate team A. If not, it will populate team B. It should be B, I think. That's what basically this means. Yeah. Okay. If we were to use AND, we would actually be using a concatenation, double concatenations. Not double concatenation, double ampersand, that's what they call it. So yeah, so here we are populated team A. So this is basically creating a column, and columns most like all columns are actually row context, meaning that they use rows. For instance, if right now, let's say I want to change this table, I want to introduce, let me say, a better way if I can explain this concept where we have a row context in the populated columns is by use of, let's say, related function. So if I change this to a related function, and I want to say, for instance, I want to know the actual customer names that are related to the customer ID. For instance, I can just change this to say customer names, because, for instance, I want this, so I can get this from related table. So we have this table is the fact table, it's related to other tables. So, and I want to actually populate the names of the customers that are actually related to the customer IDs that are present here in the fact table. So if I use related function here, so this one will populate. It should automatically have the closing. So it will populate the customer names here that are actually customer IDs in this table. So this purpose, for instance, whenever you're doing any, what it does is populate. It actually looks for the rows. It brings, or maybe let's say, it brings the best way to use is actually it returns the rows that are actually the customer name column from the customers table, and it actually relates to the customer ID. So we have the customer ID here, and we also have customer ID in the customer. So this is basic of understanding. So the best time to use the calculated columns is when you actually want to do a comparison. For instance, right now we want to see the customer names that actually have carried out some transactions in the, let's say, company called right now, for example, Pot and Hammond. We have sold 500 cases, or volume of 500 cases to this customer, and the customer ID is 16. So in that way, you just want to analyze is the best way to use when you're using a calculated column. But whenever you're doing a calculations or any sales calculations, it's not the best. Let's take another example. If you want to use to actually get the sales, we want to get the sales. So let's say we have sales meaning that in this table we have cases sold, right? But we don't know the price. It doesn't have the price that we've sold our wines. So if you relate this table, if you look at the table, this table called wines, let me just click on wines. I'll come back to this, no problem. Let that measure create itself. Let that table column create itself. So if I click on wines, Yeah. If I click on wines, I view this here. In wines, yeah, this table I have wine ID, wine itself, supplier type, country, wine country, and we have the price per case and we have the cost. So this is the actually price at which this company, whose data we're actually using, are selling. And this is the cost price, is the price at which they've actually bought. For instance, if you look at this wine ID 1, this is Bordeaux wine. So this wine is actually supplied by this supplier, and they have actually sold to these guys. Or maybe let's assume this is our data, this is our company. Let's use us. That is easier. So let's say, for instance, it's us who are actually making this sales. It's us who are actually selling this wine product. So this wine ID, for example, Bordeaux, this wine, we have been supplied this wine by this company called Lightweights. Is my screen still on? Am I?
No.
You stop sharing.
I think I'm having a network issue. I don't know why. Let me try and reshare again. It just went off.
Okay.
The problem. All right, so we're here. Great. Yeah. So here we have like, this is the price at which we've bought the wine, 25. This is supposed to be US dollars. Okay, so it's good to actually always like check the data. We've not done that, but we can actually do right now. But no problem. We'll populate later ahead, and then we'll use that. But then most of the times, whenever you see they have this kind of data, first thing to do is look at the format when you're doing when you're actually doing the transformation. So you can just change these to both of these tables. We can change the format to currency. And change to currency because these are sales and purchases.
Number 2 3 2. Jolene, please mute.
Okay, great. So yeah, so here, this is, listen, for instance, this is the price at which we bought, and this is the price at which we're selling. Later on, we'll check out these high profit wines that we have actually making these sales later on. But for now, these two tables, if I want to know the sales, for example, we compare the price we're actually selling per piece. Yes.
Before you proceed, is it possible also in this Power BI to change, for example, the currency perhaps from dollars to euros, to change different currencies?
Okay.
Or is just automatically by US dollars?
I think it is. You can change from the setting back then. I'm not so sure, but right now, yeah, what normally happens is you can change from the setting. Here, options and setting. But I've not tried that. But it has an inherent way of actually just populating for US dollars.
Oh, okay. Yeah. Yes. Okay. Yeah. Thank you.
Yeah. So I think there's somewhere here. Yeah, you can explore that. So. Yeah, the US dollar is so powerful that no one even thinks about any other thing. Yeah, great. So if you look at this, if you want to know the total sales we make for each wine, what we normally do is we actually compare the price per case we actually here have and the cases we have sold. And the cases we have sold are in wines table, in the wine sales table, which is basically the fact table. So we were actually creating sales. Here a column called sales. And this column called sales will have the sales, isn't it? So the sales will be so the wines, the cases sold from the wine sales fact table. We multiply this with the actually cost per case here. In this wines table, we have the price per case. So, but you cannot just do that. We have to actually make sure we bring in a related function, which actually helps us to make sure that we have the cost per case. So this will give us sales. Are we together here? This is just normal elaboration of understanding. So the only thing I've brought in here is the related function. The two ways of approaching this. So the first way is this. But before I go to this, let me just copy this and come back to that. The other way of doing it is actually getting related functions and returning the price per cost from wines price per cost from wines table, dimension table. So instead of writing sales here, I can write this one as maybe, let's say, price. Let's put price, and then this will populate a column called price. And then I'll create another column. For me to get now the sales will be the product between the price column that I've actually returned from the wines table, multiplied by the actual cases sold. So let me create another new column here, and then this new column will entail now the sales. Which equals to, now we have the wines, both now we'll have the wines. So we have the cases sold, or we multiply the cases sold with the price. So this will populate the values that we actually were looking for. These are the sales we've made. And now when we have this kind of sales, the first thing to do is change the whole number to currency, and also make sure that it looks like multiplying does. Anyway, so yeah, instead of having two columns, because columns use normally rows, and what actually, instead of having used, the best way is actually having one column. The way we have actually started with one column that returns value from the related wines dimension into here, and then we have actually a something like a related function that actually can find the price per case values from the wines table for each row in the wines table. It keeps in the memory, then we multiply that by the cases sold. So that is something that is not so difficult to do. So I would want to actually get rid of this table. This column, not table, this column. And then I have only one column that actually performs the job that I want. So where am I heading with this? Where I'm heading with this is actually, whenever we are doing this, what we're doing is we're doing a row context. And it's not the best thing to do when you're actually doing a calculated columns, not to go with cells. So let me just edit this sales column. And instead of having this, because now we don't have any price, so instead of doing this, I can have cells. And I have wines cases sold. I multiply this by the way we just said. We actually are going to return a value from the related from the wines table by using a related function. So this is going to be price per case. So what does this mean? Now what this does is basically it just actually finds the price per case values that are actually in this wines table, from the wines table for each row that, for example, the first row for each row in the wine cell table. So it keeps that function in the memory. Then that's why we are multiplying that by the wine cells case sold. So once we do this, we are going to actually have those values populated straightforward. I'm not saying this is the easy way of doing it. I'm saying this is less efficient. Why? Because we're using a row context. So the DAX expression it will do is it iterates over the row of this table, the wine cell table. So this iteration is looking for the rows and finding values from the price per case in the wines table. That actually is inefficient, and it's not a great idea. So the calculated column typically would evaluate for every row in the wines table, wine cells fact table. Then whenever we do any refreshing, for instance, sometimes you might want to actually do other tables or create other tables, or even create other measures, or even calculated columns. So whenever there's a refresh, of the data refresh itself, then there's a new calculation that takes place. So this actually is not an efficient way, especially if you have like millions rows in your fact table. It takes time, it's inefficient, and that's why we normally tend not to actually use cells or any DAX calculations when you're actually calculating for columns. For columns is for comparison. The way we just said, for example, we're looking for another thing we can do with calculated columns is if you want, for instance, to see the regions, for instance, that actually we are making sales to cases sold, you can just bring call back or return those region names from the wines table. No, not from the wines table, from the regions table dimension, and see that the regions at which we actually have sold more cases too. That's easier by comparison. Then later on you can get rid of that. But having a cells and this kind of cells inside the table is not an ideal situation all the time, because it slows down, especially and imagine if you are, for instance, let's say we have cells, right? Let's say in a case where we want to visualize this, and the visuals here, I'm just going to use tables because tables are the easier ways to explain things that are happening behind the hood. So if, for instance, I want to actually see the wines and the cells we've made right now. So I want to compare, for example, the wines that I have and the cells we've made. Yeah. We can see these are the cells we've made. The cells we've made. Okay, great. I can see we have. So these are the cells we've made. So it's not, whenever we are doing, actually, whenever data refreshes, and whenever we're visualizing, now it took time. I don't know if you have seen, it took time, because what it did was it also calculated the sum of these dimensions. For example, if we have other dimension table here, so what it did was, because here the cells had a function of that was actually being called from the wines table. So whenever we actually do any refresh or I want to visualize, it also takes time because of this taking the sum of everything. So it's not the greatest way of visualizing. It's not the greatest way of doing whenever you're actually doing populating for cells. Another thing that I also wanted, I have not covered, is actually you always check on unmatching values. Unmatching values are, for instance, let me get a good example here. I can just maybe unfilter this, I remove these ones, and then I check. It's good that it's also like be present, because I want to show it later on. Like start with wine, and also the order at which you're doing this filtering is also very important, and key to the DAX engine is also, those are the basics, but we'll actually cover that in short. So for instance, what I want to do is I want to see the unmatching values. If I go back to my tables and I click on, for instance, wine cells, and I see once here wine ID, I check and filter for this one ID. I have like 13. I don't know if you can see I have 13 checked here as the wine ID. And if I go to wines table, this is the dimension table, because these two tables are related and they have a relationship through the wine ID. And if I check for the wine ID, I have 14. So what does that mean? It means that there's an unmatched value. So there's an unmatched value. It means that here we have 14 and this one we have 13. What does that indicate? What does that mean in real life? It means, remember, we said wine cells contains the cells we've made. So whatever wines we've actually sold. And in the wines dimension table contains a description of those items, that entities that we're selling. And it answers the questions like why, and like how. So in this case, it means that there's a wine that actually we have not sold. That is like we have an extra wine ID, so we don't know what that wine is. So if you are enough, if you can easily look at it and then see, probably you can say it's a Lambrusco wine that we have not sold. On the other hand, you can also look from this visual. The way to look from visuals, because this visual contains wine and wine, some of the cells, you can click on the drop down of wine and then click on show items with no data. So then you can see that this Lambrusco, I don't know how to pronounce it, but hopefully I'm hoping that it's pronounced as Lambrusco, those who are familiar with wine. So it's called Lambrusco. So it's Lambrusco that is actually, that we have not actually made any cells. So yeah, that's how we basically can check. One of the first things to do is check those kind of magic values and magic values to avoid issues with blanks. This is in a case where we had an extra item, or for example, an extra entity in our dimensions table as compared to the fact table. In a situation where you have a let's say, for instance, if I go to my tables and I go to click to wine cells, in a case where you have values, for example, a wine cells that are actually not values that are not matching in the wines in the dimension table. Right now we don't have here. Here we have, it's fine. But in case we had, for instance, here instead of being 2, we had like 500, 400, and 300. And then we have like 1, 2, 3. Those are wine ID in our wines. We have those unmatched entities. what normally takes place is when you do the kind of right now much filtering we've just done in our visuals, it will give you a blank. This first part's going to be a blank, and the main reason for that is because we say it's a dirty data. The data has not been actually modeled very well, so that means there's a missing data. So someone has to go back, and the person who's doing the data modeling has to actually cross-check what kind of values. So make sure that even if you can easily do analysis, if your POC table has more the entities, more data, make sure that you go back to your data and see where you're not actually where you're going on, because there's unmatched data compared to your dimensions table. But if you have more data from your dimensions table in your dimensions table, and you have less entities or less columns, not less columns, less information or less entities is the right way to use it. Less entities in your POC table, then you can actually make a deduction on why that is the case. So yeah, that's totally okay. I think it was just a small thing, and I'm sure it's basics everybody understands. I just wanted to actually also make sure it's covered. So yeah, we were talking about the tables. If you have any question, kindly just unmute yourself and stop me and for further clarification. Yes. So we said when we are doing any this kind of cells calculations in a calculated columns, it's not always efficient. So the best way to do is actually create measures, and that's why we need now to discuss about what measure is. Our next slide covers about what measure is, and then we have tasks. So for those people who maybe have already opened their DAX, the Power BI, we can also do these ones together. We'll be just very fast. So we have a measure, for instance. A measure is a DAX expression that is used in Power BI Visual to return a scalar value, and is evaluated in a specific filter context. So when you hear it's evaluation, because you can have a measure, we'll go back, we'll see. You can have a measure, but the measure has to be evaluated based on something, right? So we see it on a specific filter context. So when you say specific filter context, this is the term that actually want us to spend some time on how this one happens and how it's done behind the hood, how the DAX engine works when it comes to specific filter context. So in other words, DAX measures filter the rows of tables and typically perform aggregations on the filter data to return a scalar value, which is a single value. A scalar value could be either numerical, it could be either text that is visualized in reports. So one thing right now it's clear to us that when it comes to calculated columns, we actually use something called the core context, as we discussed right now. And then whenever we're actually doing a measure actually uses it's used in the report, and the measure uses it's evaluated in a specific filter context. We'll actually explain this further. So here we have a task. We have been told what is the total case sold for each wine, average cases sold, number of sales for each different wine, and total number of stores. So let's actually try to actually create these measures, and then we try to explain how these measures, how the specific filter context is carried out behind in the memory of actually DAX engine. So good. So the first one is asking us to calculate the total cases sold for each wine. Okay, cases sold. Here we are talking about measure. So we are creating the measure in our fact table. So there are many ways you can do that. So you can either click here and then you have here, then you can either click on new measure, or you can just click on here and then create a new measure. So I haven't discussed the differences between the explicit measure and the implicit measure. It's in our notes. Implicit measures are actually simple measures, but they have a limited use to us. But explicit measures are the ones right now we're working with, and explicit measures are actually measures that can give us whatever we want. So explicit measures allow us to allow us to actually edit the format, the numerical. It has a lot of advantage as compared to the implicit. An example of implicit, in this case, an example of an implicit measure will be cases sold. The cases sold, we have this sigma. Sigma will actually show that whenever we input this sigma or this column into a visual, it will do a summarization, or it will do an aggregate. So that's why we have the sigma here in this case. So this is an implicit. So we can work with this one, but normally what happens is it has a limited application. We can work with it. It will automatically, if we put this one in a visual, to give us some We can work with average, but limited. We can't do with many. We can't work with. That's why we need explicit measures, which actually have a total
Ahmed
control.
Kadir,
Yes.
there's something that you talked about. I don't know, it's sigma or something. Can
Yes.
you try to explain what it is?
Okay. Okay. Good. So here, whenever you see a sigma, this means that
that symbol is
value
what we call the sigma.
Yes, this is called sigma. Yeah.
Okay, thank you.
Yeah. So whenever you see a sigma, this is a Latin word for sigma. It's just some summing. So we've done this in primary. So if we, for instance, want to see, if I want to, let me come back for this measure. I will explain. Go to the visual. I think I already have created a visual that actually has cases solved. Yes. So here you can see that if I click on this drop down, I can click on sum, don't summarize, average, minimum, maximum, count, distinct. So these are the functions. So if you look at this, for example, sum, average, minimum, maximum, count. So most likely this, especially these first four, these are aggregators, right? So they summarize. So we have this, but in case I want to actually embed in other, for example, let's say iterators, for example, aggregate x, sum x, I can't use with these implicit functions. And another disadvantage also is like whenever I want to change the name, let's say I have some of cells here. If I am to change the name of this sum of cells, this measure, it won't reflect on here as well. Another disadvantage also for the implicit is because if whenever I want to work with this implicit function, I have to always, like, if I want to work with average, because by default it gives me the sum, I have to actually change the average all the time. If you compare to explicit, you just create that, and if you want average, you create average. If you want to name it, you can easily. If you have a measure here, you will drag your measure, explicit measure here. Then you can name temporarily without having to change the name of actually the name of the column. It will change, but the name of the measure itself won't change. So those are some of things, but it's basic. Everybody gets it. That's why we ought to use explicit, and I jump to explicit without having to worry about the meaning of implicit measure. Where is my measure? So it's never created. So let's create our measure.
So in other words, the implicit measure, these are the measures that you don't code, you don't use DAX. Just use the inbuilt features in Power BI.
Exactly.
But now the explicit, these are the ones that you use the DAX formula to calculate.
Exactly. So any measure you've created using DAX, that is called explicit measure. Yeah.
Okay, thank you.
No problem. So the first measure we asked to create is total cases sold for each wine. Now we call this total cases, isn't it? We call it total cases. Let me just use caps for the columns to have uniformity for those cells. One thing also, like I think also forgot to mention, which is very basic. Whenever you're referencing your table names, you will never see me actually using any single quotes for now, because my tables are actually have all alphabets. For instance, you have wines, tells people there's no space in between. For example, date table, regions. If we have a space between the name of our table has a space, or it has a let's say a special characters, then you must actually indicate you must show the single quotes for you to actually call or maybe reference that table. Yeah, the best way to do is, like, for instance, your cells, if you are using table names, best way is to use either numericals or alphanumericals. For example, you can use like cells 1, 2, 3, like those kind of things without have any issues, because getting the single quotes all the time is kind of so for instance, my tables don't have any space, so I don't need to use any single quote.
But in case when you use it, it will still work.
Yeah, it will work. If I use, for instance, right now, what I'm trying to do is total cells. Let's try and use one. Total cells is equals to, we are using sum because we're summing all the cases that is actually being sold in the wines table, isn't it? So in the wines table, so I can single quote, then I write wines quote, wines cells. So I have here, okay. So it still work. but I can easily also omit that sort master I use. So because my tables are quite perfectly fine. So yeah, cases solved like that. So here, if you have an issue, what I've done already for this specific DAX, you can just stop me, please, because we are asked to get the total cases for each wine. So we're getting the total cases is basically we have all cases here, cases solved. We just get total. That's basically the sum. So we have total. That is the first measure. First, so that you can interact very better and everybody participates. I think one of the reasons why I'm doing this one is because we will use later subsequent DAX expressions and functions. We'll use the same here. To see that why we are using this. Like for instance, I've created a sales calculated table column. That one will come back for it later on when we go in depth analysis of these measures. So my next is average cases sold. Average cases sold. Nehemiah, what do you think this wine sales this measure will look like?
You'll use average.
Average, yes.
Function.
Average bank function, yeah. Just that simple. So you can just name it as AVG average. Is it sales? Average cases, still cases. We're still on cases. Average cases equals. So we can say average. Average. So we have wine sales, and then we have cases sold. Third measure is asking us to actually compute number of sales for each different wine, number of sales for each different wine. So this one is anyone who has an idea who can tell us number of sales.
Can we do a count? Can we use a count?
Very true. Yes, we can use count. Yeah. So count is now we're going to count. So a number of sales. So remember what we said, number of sales, correct? So remember what we said is like this table, wine sales contains the sales transaction. So everything that it has, it is the sales. So what we want to count is the count rows. We want to see the number of rows that it has because this table deals with the sales, with the sales transaction. So the function to use here is count rows, wine sales. Yes. So this one will give us what we want. So number of sales will be the count rows, the wine sales table. So the wine sales table contains the transactions, sales transactions. So we need all that first to know the number of sales that has actually been made. All right. The fourth is the total number of stores. Total number of stores. So anyone with an idea how we can compute this? With asking total number of stores. So we have stores, I think, in we don't have it in wine sales. Stores, we have it in customers, most likely. Let me just do that. Yes, number of stores, and you can see it has what? It has the sigma. So this we have to get the sum of this. All right, number of stores. So let's continue with our measure.
And again, can we participate? I see you have a good team here, Jose, Lauren. We have serious people, Nemo. Can we participate kindly? Even if it's just to add something, to comment, or to respond.
Yes. Yeah, exactly. That would be really good because it shows that we are together. Yeah, it's asking total number of cells. Total number of cells. Can you see number of cells? Total number of stores. Sorry. Total number of stores. So it's going to be the sum. And then we're going to reference the customers table, number of stores. so that we can get a sum of all those. All right. So now we've created these measures. But what's the use of this measure? That's the question. Now I've created the measure. I've thought about it, yes, but what's the use of it? It's like now I've answered the question, but we don't even know what we have done. So this measure to be evaluated, the measure to be calculated, it has to reference something. It has to actually be evaluated based on something. So that is why we actually have to use a filter. For example, in this case, we are going to use a visual. And the perfect visual that I actually want to use all the time is the calculated tables, which actually will make sense. The table visual, which actually makes all the time make sense with me. So let's actually try to actually remove the cells. And before I even go that, let me mention one more thing. That is, we have the measures. So your measures can be distributed. Now we have like 1, 2, 3, 4, 5 measures here. So we can, 4 measures here. This is it. We have 4 measures we've just created. So the best way to do sometimes is to create a measures table. When you create a measures table and then you take all your measures in that measures table, it's easier for you to reference later on. And it's easier also to talk about how you're. For me, like it feels easier. For some people, they would prefer actually having their measures in the table they've created. But I think it's easier and it's more efficient when you have a table itself that actually covers measures, and it's called measures table. So let's create a measures table for this case, and then we store all our measures in that table. So that later when we want to reference, it will be easier.
How do you know? Can you scroll down a bit? There's something that
Okay.
when you want to know perhaps something is a measure, it has that symbol. Right?
Yes, the calculator. This calculator is a measure. If it has like you see this kind of a summation, it's a column created. Yeah. So this is especially it's the one that actually have created. Yeah.
Okay,
so,
thank you. So this is calculated column, and then this one is measure.
Yes, measure. Yeah, but this one's date. This is calendar. It is normally inherent. So I haven't done anything to do with it. So other dates is actually it has. So it's actually a calendar. So but when you see a calculator, it's measure.
That's a measure. Okay, thank you.
So, yeah, let's create a table that actually has only the measures, and it's called measures table. Let's try and create that. Right. So the first thing we actually click on enter data. So when we click on here in our home tab, we have click and then we name this one as measures table. Let me just use measures table. I'm not paste, it's just the way so that I can easily reference later on. So it has a measures table. So we load this. So this measures table will have, I think, only if I click on here, if I expand this, it will only have one column that is empty. So we will delete this column, but only when we actually store our measures here. So how do we put these measures here? So the best way is clicking on the measure itself. So when you click on the measure itself, you have home tab here. So you click on this drop down, and then you actually take it to the measures table. So it will move from the wines table and it will go to the measures table. Okay. So this measures table, it's not a measures table. If you look at this icon is showing that it's just any other table. It has columns, but it's not a measures table. But we'll make sure that that is the case later on. So we have the average cases in our measure table. And then we also go to number of cells, which we created. Yes, there's someone trying to speak.
Could you please repeat how you created the table, if you don't mind?
No problem. I'll do that. Okay. So let me get rid of it, and then I'll start. That would be easier. Oh my goodness, what have I done? No one could. You guys should have stopped me. I've actually deleted 2 of my measures. I have to recreate again. I've deleted 2 of my measures, and those 2 measures I have to recreate my 2 measures. Then those are what? So we have total cells and we have total number. So I have to create total cases, average, and okay. So let me just repeat my measures and then
Let me ask, in Power BI, there's no option to undo or redo.
In this case, I don't think I've deleted from the model. So if you do the deletion from the model, it's gone.
Wow.
Yeah, you can undo some steps by using this one. But now if you do a deletion, I don't think we can go like that. So it's like you have to reload it again. But now the good thing is what we'll do, I don't have to actually create the measures right now. So we have understood, I'll create the measures within the measures table when we get there. So right now, let's just get the actually again. So the first step of actually creating the table in the measures table is by clicking, we are in home tab here in this tool. So you go to enter data. When you create on enter data, it just this pop up for the create a table. And then here I've just changed the name from table to measures table. So when I have this now, I just load it. It has a column here that is empty. There's no issue with that. We are going to get rid of it later. So it's just normally the way you normally create a new table, and then you just name the table to actually whatever you want. So you have a measures table. But remember, when you create the such table, that such table is just a normal table that contains columns. That's not a measure table. So for us to create the measure table, we will move all the measures in that measures table, and then we will get rid of the column. Then that date table should change its even look. So right now it has only that column. So let's move the rest, the two measures we've actually remained with, then we'll add the other two. So we click on that measure, and then we go to the home tab from the wine cells where it is right now, and then you click it on the measures. So I think it will go to the measures table. And if you mistakenly take it to somewhere else, this is the easiest way of actually getting it back. Sometimes you would see someone when telling you like you can drag and drop, but it won't work in this case. Maybe if someone else has an idea, you can also let us know. But I think this is the most efficient and the most correct way of doing it. So we have these two measures of create total number of stores and the total sales. We need to add the other two. So I can click on the measures table and then click there. I click on the measures table, and then I have the new measure. I add the first two. The first two are the average and the total cases and the average cases. Okay. So the total cases equals sum. Sum of wines, and then we have wine sales. We have the cases sold. And then the second measure was the average cases sold. So either way you could start creating the table, may call it measures table, then create all the measures inside there, or you could create all your measures wherever it could be. It could be in any other table for easier understanding, and then later on you group them into one table. So this was called average cases using average function. Then it was wines, and then wine sales. We have the cases sold. So let's just confirm that. Average cases sold. Yeah.
Average sales.
Average cases, not sales. We have cases sold, not average sales. The question was asking average cases sold. So we're just looking for the average, not sales. We're not doing the sales yet. Is that okay?
Okay.
Wait, average cases. So it's cases sold. Those are like the cases, the numbers, the volume, but not the sales. Sales is different. So sales is like now when you multiply that cases with the prices per case. That is when it gives out the cases, the sales. So we're not doing the sales right now, but we'll do initially. Ultimately later on we'll do, which when it gets more complicated. Right now we're just like touching the surface of everything. So now we can get. So if you look at this table, Measures table just looks like any other table. It is so why? Because there's a column here. So when you get rid of this column, this table will only have measures. So the look of this table will also change, and then it will look like it will have a calculator. Then that means that actually table is a measures table. So let's actually, what am I deleting? Column 1, right? Yeah, right. Yeah, you guys should be very keen. I can be very clumsy at times, and sometimes I'm very forgetful, and that's what being 40 years old means. Okay. Anyway, yeah. That's it. So now you see the measures table has changed. The measures table has changed. I'm not 40. Whoever thinks that I'm 40, I'm not 40 yet. So we have measures table. Now the icon has changed to calculator. Now you can distinguish these tables now. So when you see this table, whether you call it even other names, you call it like Nehemiah YouTube channel or anything, you'll see that that actually specific column and the table contains only measures. Yeah, so it's easy to reference later on when you're doing this. And whenever you're referencing a measure, we use a square bracket. We'll also get there. No problem. I think that's that. So we can move to the next slide. So before we move to the next slide, there's this element of specific filter context that I actually wanted to explain. And it says, for instance, we have all DAX measures are evaluated in a specific filter context. I want to actually explain this right now. So how are we going to do that? So let's, for example, use a visual. The best way to explain will be a visual. Anyway, I can get rid of this. I don't want these values. What I want to compare is, for example, the wines, and I want to compare the wines with the best way to explain is the total cases, for instance. Let's say, I see if this will give me not total cases. I want total sales. Why do I have total sales here? What was this measure giving me? Yeah, total sales. Thank you. No. Okay. Let's use the cases sold, and then I have the cases sold. Let me make sure that it's variable. Sold. Then I can add now total cases. Let's see if I want to have a visual that actually can explain what I want. Total cases. Okay. Let's see. Yeah, total number of stores. Let me use the total number of stores. That will make actually a good explanation. Total number of stores. Good. And then I go to cases sold here, and then I actually get that, and also, yeah. So yeah, good. So let me expand this. So here in this case, for instance, I have two measures, right? I have a measure that is the sum of the cases sold. No, that is, I remember, this is also a measure that is implicit measure. And then I also have, instead of even using, let me just use sum of some. It's still okay. If I use sum of cases sold and total cases, will that be the same value? Will that give me the same? Let me see what that measure was reading. Let's try. So let me just uncheck this. I'll also uncheck this. I start with total cases. Yep, I think this is better. Now I'm using two explicit measures. Instead of using implicit and explicit to confuse people, I opted to use two explicit measures just to compare the two and so we see how measures work. So you see, we have two measures. We have total cases, and then we have total number of stores. So we have total number of cases are changing. For instance, for each wine, we have different total cases that are actually sold. For example, here we have 4,000, we have 10,000, but we have, for instance, for the total number of stores is the same. It means constant. Why? Why is this measure giving us different values, and this measure giving us the same constant value? That's the question. It means there's something that is taking place behind that we don't understand, that we need to understand. And in a case where if I want to calculate the number of stores in which each wine has been sold, it's not giving me, it's giving me a sum of all the total number of stores up to here. So what's happening? That's the first thing I need to understand. So the way the measure works. So the measure normally, in this case, what happens is the first thing, we have this column. And the first column is the wine column in the wine's dimension. So there is a filter context that is placed on this column, on this, for example, wine column, and the first instance, Bordeaux. So what happens is that the first time a filter will be placed on the first table, on the first column, especially the first column, and the first instance it comes across is the Bordeaux. So it will calculate a value that will give you the total measure. A value, for example, if it's 4,007, that's the first value to give you the value for the measure of the total cases measure. This is a total cases measure. It will give you that value. So how is that one happening? And what happens when it does that? So when it actually filters for Bordeaux itself, if we go here and check between these two, we are talking about the wine's dimension and the wine sales. So we say a filter is placed on the wine's dimension, specifically wine's column. So once and then it actually locks Bordeaux. For example, the first instance it comes across is Bordeaux. So it wants to evaluate the measure, a value that actually calculates the. It wants to evaluate the measure and then calculate the value. So what happens is, first of all, it actually filters for the wine, and then the filter is propagated to the wine cells. Are we together? Because here we have one-to-many relationship. The filter will be propagated to the wine cell because we want to calculate the number of cases sold. So it will. So when it's propagated to the wine cells, so that table will look like a table that only has been filtered, but remember it has been filtered to Bordeaux itself. So that wine ID number one, for instance, it's number one. If I try to actually make this is all these things happen in background. So those tables that are created are like tables. The table that, for example, is created after the propagation of the filter is known as cross-filtered wines actually sells fact table. So let me try to explain in a better way by actually trying to have a table. I want to it doesn't exist. This is actually happening behind the closed doors. It's behind the hood. It's happening, but I'm trying to give the closed explanation to that. For instance, when it comes across the first. Oh, it's happening like this. So I'll actually go to the wines table. So we said the first column was the wines column, right? We had the wines column. Remember from our tables here, we had from our tables, from our visuals, we've actually started with the wine, this column. So the filtering will take place, filter context will take place in this column. So let's try to explain that. So here, what will happen? It will automatically, it will actually filter out. It will filter this one to. It will filter to only wine ID number one, and then, or it can even filter. Instead of using wine ID to confuse, let's use wine. It will filter wine to only Bordeaux because the first instance it has come across is Bordeaux. Okay. Let me just select Bordeaux, and then I click OK. So it will look like something like this. So we say the first instance it has come across the wine column of the wine table, and the first instance has come across is the Bordeaux. Then this will be how the filter looks like. So you see, so this will be propagated. It will be propagated. The filter will be propagated to the wine cells. Now, because our measure is asking for cases sold. Okay, so it will actually propagate to this. So how will this table look like? This table will look like now a table that has filters of only the sales transaction of the Bordeaux itself, Bordeaux wine. Okay, so that is how it will look like. And when it does that, it now sums all the cases sold for that specific. So I hope it makes sense. I've made sense how that actually filter is actually created here. So when it does that for the first, now it moves to the next evaluation, which is now it goes to Champagne. So when it goes to Champagne, it filters for champagne itself. Now the filter is propagated to the wine sales table, and that wine sales table is filtered. The wine ID will only be for that wine ID of champagne, and then now it sums the total cases because there's a column that actually calculates the cases sold. So it will calculate, it will get the sums of the cases sold for that. Now, when it moves to the next subsequent evaluation, that's what it does until we get to that point. So that's how it performs, for example, the cases sold. So that's why we say measures are filter specific, or maybe they actually are evaluated using specific filter context. So this is one amongst the three filters we'll discuss. So we say when a measure is placed to any visuals, for instance, we've now placed a measure into these visuals. Before the measure, first of all, is evaluated, what the DAX engine does in memory is actually it filters the tables in the data model in on three factors. The first factor, it uses the column placed in the visual, this one right now I've discussed. And then the second one is the column in slicer. For instance, if I was to use a slicer, we've used all these things. I think when we're doing our Majindogo, we've used all these things. It's just that we never understood what's happening behind the hood, how the DAX engine is actually doing all these things. So, and how our actually cross-filtering takes place, and how our data structures was actually having an influence on getting the right measures, wrong measures. So you might find sometimes when we were doing those MCQs, we were doing those measures, we were getting values, but they seem right, but we were getting wrong. So because sometimes you might find even your total measures, because someone might tell you, for example, 423, 204 is a measure, is addition of this. No, it doesn't the case. So what the measure does, when it gets to Shiraz, for example, the measure, because the wine, it was using the column wine ID, for it to populate the total, it won't do that. How it populates is it actually leaves, it actually, what do you call it? It actually removes the filter for the wine column, because after Shiraz, we don't have any other column that actually in the wine column. So the total column is populated only as sum of the wine total cases. And that's how it's populated. It's not actually addition of all this. No, that's not how it does it. The way that engine functions is different. For this one, it's filtering with Shiraz is actually propagating the filter. But when it gets to the last one, it actually there's no filter anymore. So the DAX function remains only to the sum of the total cases. Yeah, that's how this 420 comes. So there will be an instance where we have actually total measures that are actually wrong and right, and we'll compare where the issues are later on. We have the time to come. So we've said, first of all, I'll just present that point where I'm actually talking about here. This is when a measure is actually placed into a visual. Before the measure is evaluated, the DAX engine in memory places filters on tables in data model depending on three factors. The first factor is the column or the columns placed in the visual that group and categorize the data. So we've checked right now. We've checked this. This is the column. We've checked that's the first column that actually being placed in the visual. The second one is the columns in slicers that are actually filtering the data in the visual. For example, if we had a slicer here, if we create a slicer and we filter something else out, it will also have an effect. That is also another filtering. And then the third one we'll create those ones. And then the third one is any columns placed in the filter span that are filtering the data in the visual. The third one is actually when we use here, if we add another column here, for example, in this filter pane, will also have an influence on this visual. So that is the main thing, I think, how the DAX engine. So that's why we say DAX are actually evaluated. DAX are evaluated in specific filter context, unlike columns. So the columns were evaluated in pro context, but when it comes to DAX measures are actually evaluated in actually specific filter context. So all these three factors come together to generate a filter context for the evaluation of a measure. So we said a measure is nothing without being evaluated. And the way to evaluate a measure is using the visuals we've just right now seen, right? So that is what we've discussed. Now, why is my total number of stores still constant? That's a good question. Someone can ask me, I want to calculate the number of stores in which each wine has been sold. I want these values to be changing according to the number of cases sold. That's what I want to see. For example, how many stores have actually sold. Bordeaux, for example, for instance, someone can ask me that kind of question. Why isn't the case? So if you look at this, remember the three conditions, the three factors that are very important. The first one is the column that is placed in the visual. So this is the first column. So depending on the structure, so it has taken this column. So this column is the one that actually the filter is placed on this. So if I explain this in the data model, we are comparing between, and remember this. Let's go back here. This number of stores is in customers dimension, right? So it's not in the wine step. So if it's in the dimension, so we can say, you can look at here and then see we have customers, and then we have wines, right? So we have to have the filter. The filter has to propagate to here. So we have a filter that is coming from wines, and then it was coming here, but there was no any filter that was placed on the customer's table that was coming here, and hence it just calculates the sum, measures the actually all values in the number of stores column in the customer's table for all the customer, instead of actually having to calculate for one specific wine. So I don't know if I'm making sense to you guys, but what it basically means is when a filter is not placed on any dimension, then it means that there will be no filter that is going to propagate. There's no filter that's going to propagate to here. But this one, we had a filter placed on that on the wines column in the wines dimension. Then it propagates to the wine cells, and we were able to see a result. But here we don't have any filter propagation, and so hence we were only getting. So the measure, that measure is specific. Let me go back to the measure. So this measure, total number of cells, will just sum all the values in the number of stores column in the customers table for all the customers. So instead of actually having to do the propagation, that is the main difference. So someone would tell me, like, why don't you just change the direction? Why don't you use by direction? Why don't you use the cross filtering? Yes, that while that can work, what normally happens is it normally complicates, and there's a lot of exceptions when you are allowed to do that. Right now we are not discussing it, but maybe if we have more sessions we can. So the best way to do it is to use something called cross filters. Cross filters normally we will also discuss. Like, I don't know, there's a lot of things to discuss anyway. I hope time will allow. Cross filters, I want us to use it to move in a very organized way, in order, because these DAX functions are the way, like, you do one, you find there's a limit, then you expand to another DAX. That's how it normally goes. You can't just jump all the time. So for instance, here you create a virtual relationship, either VLOOKUPs or you use basically the cross filters. So the cross filters are we said are table modifiers, right? We said calculate table modifiers. So those are the ones we normally use. We create a virtual relationship here around, and then we will be able to actually have what we want. When we get there, it will becomes very simpler, because we come back to this relationship itself. Yep. So I hope I actually made sense. Let me just remove this filter. Right. Yeah, so that's why we have these values to be constant, and I'm sure I have seen this kind of things many times when I was actually doing this work. So and I was raising a lot of questions to myself, and why that was the case. But now it's clear that how the DAX functions is that you have to have a clear relationship, and for the filter to propagate to your actually bucket table. So for a good relationship, or normally the filters propagate from the one side of the relationship. All of them you could check. The filters propagate from the one side of the relationship to the many side of the relationship. Basically, all filters come and actually to the bucket table, because what you're analyzing and what you're looking for are actually in the bucket table. So we say that bucket table is formed by looking at the data that actually you're setting to analyze. So if it answers your what, then all other things, and it holds summary of the filters and the grouped data or values by dimensions. So that's how maybe DAX measures are actually all of them created. All right, let's move to the next slide. So this one is not important, just talks about aspects of measures. We move to the iterators. Now there's a question now. We've actually described measures. We say the measures are actually evaluated using filter context, and then we say columns are evaluated using row context. Having those two in mind, there are, to make your life more difficult, there are instances where you are actually DAX measures use both both row context and also the filter context. And those are times when you are actually using something known as iterators. So let's have a look. When your measure contains an iterator, we'll actually look what iterator is. Then it means your actually measure will actually be evaluated based, first of all, on the filter context, then on the table context. On the row context. So both of them. So to make life difficult, they have said iterators bring problems. Now, whenever you use an iterator in your in your DAX function, it will use both context, that is the row context and the filter context. So these functions are iteratables in the evaluation of DAX expression. So any function that ends with x is an iterator. Okay, this is the just general way to understand. Any DAX function that ends with x is an iterator. So an iterator, from the name itself, okay, it iterates tables, okay, when you're evaluating DAX measures. So x, for example, we have x aggregators. These are sum x, average x, max x, min x, and count ax. So all these ones will hopefully create measures for this. So in this case, that's the first one. Now the second, there are also x iterating functions that aren't aggregators, such as concatenate x and then rank x. So we'll also have in-depth analysis of these two, but these are also iterating functions. And then to make life also more difficult, we have that iterators, there are iterating functions that don't end with x, such as filter and add columns. So add columns, interestingly, add columns and filter, especially filter, we'll discuss filter very in depth. Filter, these two also are iterators. How are they iterators? We'll actually maybe look at it inside of us, so we don't need to have a discussion around that. Let's now deal with the iterators, and then we see how our next step. So measures that include iterating functions use row context in their iteration, then use filter context to generate the scalar value. So we talked about what filter context is. So filter context could be of the three, using either the columns that are actually placed in the visuals, either the columns in a slicer that are actually filtered in the data, in the visual, or the column that are placed in the filter pane. And then we have also the row context. So it iterates the row context. It actually looks, or it actually in a top, it's like it's looking for every value that is in every row. Any value that is in every row. That is what basically row context I can easily describe. So let's talk about aggregating iterators. These are the sum x functions, and actually the functions that are actually like other x function, that is like average x, all of them. So some function, what does sum x does? Sum x returns the sum of an expression evaluated for each row in a table and has the following syntax. So the syntax for this is actually sum x, table, and expression. So, so we have the sum x, we have the function, we have the expression, we have the function, and then we have the table, and then we have the expression. So this is how it looks. It's easy to actually understand, like to grasp the way it looks like, but what it performs and how actually the iterations are made is what's more important when using sum x as compared to the sum. So we say, for example, the tables is the table we want to perform the calculation, and expression is the calculation you want to perform for each row. So this one gives you the row context, and then what happens? So the sum does an iteration. This gives you the row context, and then we have a filter. For example, if we in our expression we have a filter, the filter does what we are talking about, the filter context, and then the sum x does the iteration. So the sum x will do the iteration on every row, and the expression will give you a filter. So a filter context. So an example here is, so we are told, for example, to predict the next year's volume of cases sold for each wine by finding any cases sold value that is greater than 100 and increase this value by 20. Otherwise, we only increase the value by 10. What does that mean? It means, for example, we want to predict the sales for next year, the cases that we are going to sell next year. And what we can say is that if the sales are greater than 100, we increase that sell cases sold by 20. And if it's not, we increase it by only 10%. So now here is what we actually need to be aware of what to do. So let's create that measure, and we call it next staircases. Let's create it under measures table. Okay. So here we say let's name it as next staircases. Now next staircases, we are told the next staircases we're told sorry about that. We told by finding, so we told let's predict the next year's cases, volume of cases sold for each wine by finding any cases sold value that is greater than 100. So that is our first, greater than 100. That is our first, and then the second, the first condition, let's say for instance, and then we increase it. If it's greater than 100, we increase it by 20. Otherwise, we don't. So this is where we're using sum x, and then we want to use, for example, we say the way the sum x expression looks like is we have the sum x, we have the table, and then the expression. So let's do the table. We are using wine sales because we're talking about the cases sold, and then now we use another condition that is the if condition comes in. Okay, right? That is the operator, which is the logical operator. Cells, then we have comma, and then we can do the expression, and this our expression is if case, if now wine cells, if the cases are greater than 100, that's to say greater than 100, then the first result true, and that result true is the wine cells cases sold. We multiply this next year, we multiply by 20%. So that 20% meaning that it's like 100% plus 20, 120 divided by 100, that becomes 1.2. Then the second one, now we are on the result fold. So what happens? If not, is we are going to increase the cases by 100, so by 10, sorry. It's going to be wine sales, cases sold. I'm going to multiply this by 1.1, that is 10%, right? So this is basically what the question is asking us. It's asking us to actually do what? To predict next year's case of sold for each wine by finding any cases sold value greater than 100. That is, now we have the operator, we have the logical operator. If greater than 100, then we increase it by 20%, and otherwise we increase it by 10%. So we are discussing the volume that you're going to actually sell next year. Yeah, so that's the measure. Okay.
So the main difference between the sum and the sum x, sum can be used, for example, to do the summation for the entire column. Then a sum x can be used to perform summation on a column, but based on particular conditions or some expression.
Yeah, not just a column.
Yes.
Even in a you can use sum x to actually also call or basically calculate a function from another table. For example, you can use related function. It will iterate. So basically, it will look for all the rows in that table, not just one row, but some it will only just look for that column. Right? But for sum x, it looks for all the rows. Even if you actually relate to another table, it will go and look for. So that's why it's using sum x. Sum x is actually like more. Is we call it is an iterator. So it iterates over all the columns in that actually fact table, and then we can also place conditions the way we are right now doing the operator and the logical operators. But when doing with the sum itself, you just use one column. You can't do more than one column.
Okay, thank you.
Correct. All right, let's actually if it has created this next cases, we move to the next thing. So it's asking also, we get also the total, get total sales. So let's actually do the total sales. We do the maximum, minimum, average, calculate. All right. So I think sum X for total sales. What will be the DAX be that? Am I or anyone else who wants to contribute? Let's do for the total. Taking time. Right. I'm trying to avoid total sales because I already have total sales here. I can just maybe just read like that. Using sum X, okay? So sum X total sales in the wine sales. Okay. So total sales, remember the way we created the total sales. Our total sales, we multiplied the cases sold, wines cases sold. We multiplied this by the related, what we are talking about right now, Nehemiah. So it can take a related function, the sum X. So we are getting the wine sales, sorry, not wines, wine sales, or not wine sales, wines. Wines table is getting price per case for that. That was giving us total sales. So this way, you can see the sum X. Now it has performed. First of all, we chosen that's the table, and then this is the expression. This expression, we came across this expression when defining for total sales, and now what it does, it actually iterates. It will iterate through wine sales. Sum X will actually, first of all, place a filter. We'll actually see that in short when I explain it. So let me just click this measure. So the first thing, it will iterate on every row in the wine sales table when it performs this expression. Sometimes wine sales, we can say what it does is not wine sales. I mean, and the sum X or the iterators, they can also reduce the number of rows. That is too complex, but we will get ahead and see. So yeah, so we've created the total sales. Let's create the rest. We have the maximum sales. Someone to give me this DAX, please, so that we are all of us awake. I know we are a small number, but we maybe participate all of us. That would be great. So what would be the next one? How do we get this? This measure. This measure says we calculate the maximum sales. Someone? Okay, maximum sales. So we say we use max X. We're using max X. So we have to actually define the table. We're still in wines table, comma, and then the expression for that. And the expression to get sales is still the same. It is the wines cases sold, wine sales cases sold. We multiply that with wines. Wine, what's that? Is that.
Are you multiplying with Abdi? Let me ask.
Yes.
Where are you multiplying with? Hello?
Yes, I can hear you.
Why are you multiplying something where the case is sold? Why are you multiplying? Because if you are looking, are we looking at the maximum number sold, like the bottle sold, or the sales?
The sales, maximum sales.
Oh, maximum.
So we want, sales. You're still on sales, maximum sales,
Okay.
not maximum number. Yeah, maximum number that we would have actually gone for other functions.
Okay.
Yeah. That's why it sells. As long as it sells, we have, this is how we obtain our sales related. So we say it's related, then we have wines.
Okay.
That. Okay. So okay, so we move to the next. Average sales. Someone to give me this. I think now the rhythm is the rhythm is okay. So someone to give me this average kindly. Average sales.
Do we have to use the average X? Am I the average?
Yeah, we're using average X. Here we're talking about the iterators. What we want to do. What we want to do is
Let me
want
ask.
to see. Yeah.
What do you mean iterate?
Iterate. Okay. So what I mean iterate is the function will go to average. Okay, let me try that average. So the function average, what it does, it will go to that table. It will scan that table, each and every row of that table, based on the expression you have created, right? So right now, if we do average for the average X, this will be average X, not average. When we put average, it's actually we can't do anything. So when we put average X, everything is fine. So what it does is
So you want to tell me if I use the normal average, what does it do?
The normal average. The normal average you cannot use on a column, right? So if I want to get an average, you can get an average of numbers that are in one column, isn't it? Add all of them and divide by the number it is, isn't it? Average of that, you can get the average. But when you want to get average X, it means now if you're getting an average of all the columns that are present in that wines table based on that expression you've created here.
Oh, okay.
Yeah, so this one is an iterator. They call it anything ends with X is an iterator. Filter also is an iterator. Add columns is also an iterator. We also checked other iterators. We said any other person who was an idea of what we said the iterators were. We said iterators were yes, we had concatenate X and also rank X. We actually will go this also. These ones are not aggregators, but these ones are aggregators. So they call X aggregators. So the sum X, average X, max X, mean X, and count AX all form aggregations. So they aggregate the results. So that's why it's called X aggregators. And then there is this one that is actually doesn't do any aggregation. That is the rank X, and then the concatenation, which does the concatenate X. And then this one that actually iterating function that does these are iterators that actually do not end with X, because you can see this one's all of them are ending with X. These are filter and add column. And I would love us to maybe touch base on filters for them and on us, because filters is very important. Okay.
Now
so we check.
Let me ask, for example, you want to do maybe summation. For example, you have a column that has thousands or millions and thousands. But now you want to focus on the thousands alone. For example, you want to add, you want to do the summation for thousands, but in that single column. Can you use the SumX despite it's just a single column, but you want to target specific values in that column?
Yeah, you can if you create an expression, yes, for that 1,000 you want to actually then that's fine. You will actually name the table, and then you actually create an expression for that.
So essentially, anything with the expression, you have to use now the X. You have to add in the extension of X.
Yes, exactly. You have to add an extension of X. Yeah.
Okay, thank you.
All right. Move to the next. So we were doing average. We did average X. So another thing is an interesting concept here. Calculate the average price that the customers have paid for their wines. Okay. Average price. So who has an idea what this is talking about? Average price that the customers have paid for. So right now, our filter, initially, remember, this time we were actually doing sales, and all sales were in the wine sales table where we were actually doing the sales, where the sales actually took place. But now in this case, what we are talking about average price. The price is in the wines column, in the wines dimension that customers have paid for their wines, and now the filter is on the customers. Okay, we want to see how the average price they paid for the wines. So in this case, let's create the average price measure. Still average. We're still on average. The only thing that has changed, I think, is just this the expression, but still on average X. So let me just paste again, and I call it this one as price. Call it average price. Average. Average price. We are actually using average X. So the table here in this case is not, it's still, we want to actually scan it on our fact table because we're talking about the fact table here. We will analyze it. Then here in this expression changes now. This now, what we're trying to do here, it says we're looking for average price that customers have paid for. So if you look at the, I don't know if it's open. If you look at the wines table has the price column. So and the wines table is not actually can just reference like so we have to use the related function to relate to that wines table and cost price, right? They have paid for, so it's not cost price. It should be price per cost. Cost price is the price you paid. It should be price per cost. That's the price we have sold to our customers. If it's us who are actually making the sales of these wines, right? So yeah. So average price, give the average X. We want to actually scan it. So the related function, what it normally does, basically, is it will create in the DAX memory. It will find the values in the column, price per column, in the wines table that are related, and then it scans the average X scans for all. It scans for all the rows that actually match this in the wine cells. Then it actually computes, evaluates the measures, basically gets the average of that. That's how it does function. So we can move to the next slide. Right. Now,
Abdi,
yes.
I thought you said cost, and I've seen there we've calculated with
Price. Yeah. The last question was asking calculate the average price, not cost. Yeah. We were asked to calculate the average price. The first few, there were three. So the first four other measures were actually, I think 3 measures were actually sales. So now in this case we are at the average price. It's asking for average price, and the average price was in the wines table, wines dimension. So we had to actually use the related function to actually return that values that are in the cost per price column in every row of that. So yeah, so we have that now. Now the other thing is I wanted to ask. We have to create the measures, but we have to create the visuals for that measures and see what we are asked to do. So in this case, for example, let me remain with the wine. First cells, I'll just use cases wines. I'll just get rid of this from the number of stores. Copy number of stores. Good. So I have total cases, right? So let's look at the first case. We were average. The question asking total sales. Maximum, average, calculated so. Price. Sales maybe. Total sales, and then the price, so average price. Total cases the same. Average sales, So basically, this is the filter. Okay. So different filter context for different measures. So we want to see actually if I'm looking for a good example to use here so that we can move to the calculate function. And the calculate function normally it comes from these aggregates or maybe iterators. So in the iterators right now, we've had these values, we've had the total averages. So if I use another filter, like for example, a slicer, I'm saying, if I use a slicer, will that slicer affect these values? For instance, let me say I have a slicer. Let me just try slicer here. I'm trying to come up with a good example to see which will give us, will take us to the next step. Is it done? Let's change everything to that. And that slicer. I have a slicer, then I use the customers table. Customer sales people, let's say for instance, I use sales people and then salesperson here. Then I see Abel is okay. So basically, I was just trying to relate the two, so that I can move smoothly to the next step. But yeah, let's actually have a look at the calculate function. So calculate function is one of the most important functions in DAX. So it evaluates an expression in a modified filter. So what does that mean? It means that, for instance, here we've seen that right now what we've just been doing. Let me just even just remove the price, the average price. This, then we'll have the average sale with average price. Okay, so we have this, right? So if I add another slicer and I have this slicer, and this slicer I want to filter based on the salesperson, and if I click on Abel, for instance, it will all these values change. What does that mean? So if I use another filter, even if I use the filter pen, everything changes. In a situation where I want a measure, for instance, I want to have the total cases, and then I want to have average sales. But average sales is a measure, and whenever I change this other, I can see from my phone it says I've stopped sharing. Is that the case from your end? Never.
Yes.
I'll just try to join again. What time do you want us to stop? Nema?
For me, I don't have a problem with time. maybe the members.
All right. Anyone who is like who has an issue with us extending maybe a little bit more? Okay.
When are we resuming the sprints?
On 8th, isn't it? On Monday. Yeah.
Do we have another session on? Was it SQL or
Yeah, I think there was another session. Someone said they'll do the SQL as the SQL on 7th. if people and Eve said if people will be available. So I'm not so sure. I think people are like we are like I think less than 10. So I don't know if people are. Is it because it's a weekend or?
I don't think people don't like maybe to read unless it is an exam or an MCQ. You'll find here
Yeah,
100 people.
and people actually yeah.
But I think what you'll do, if people feel like they are tired because we are recording, we
Yeah.
shall put it on YouTube and then they can watch. Because
Okay.
if we pause, it will
Yeah.
mean we'll not have another time.
Okay. That's fine. That's fine. That's okay. So yeah. So for instance, there's a good case that actually I want us to present, and for instance, let's say we want to actually, in this case, we have when we click on Abel or any other salesperson, these measures change. So, but what happens if I want a measure, for example, average sales, that measure not to change when I click on the salespeople, and the rest of other measures can change. So that is when actually calculate will come in, and calculate functions normally are one of the most important. So, and we can go through that now. Calculate evaluates an expression in a modified filter context. So it will basically modify a filter. So we said we have a measure. The measure has already filters in it. So it's a filter specific, evaluated through filter specific. If the filter is has come through the column from the column that has been actually inserted in the visual, then we can, and we want to modify that filter. The way I've just right now said, we want to modify that filter, then we use the calculate function. So, so we will have an example of that. So the syntax of the calculate function is like calculate, you have the expression, then you have filter 1, filter 2, and so on. So where the expression is what you want to calculate, it, this can be the DAX expression or a measure that defines an expression. Filter 1, filter 2, etc. is how you want to filter the expression or a measure. You can have multiple filters, and these are combined in an AND logical statement. So in this case, first of all, we say calculate takes an expression or a measure. So it can take an expression or a measure that evaluates it in a different filter context from the active filter coming through from visual, slices, or filter pane. So we said these are the three conditions, these are the three factors that actually measures use. As the active filters that actually we first of all started with, for example, we say the first column that is inserted in the visual and coming from the visual, and then we have the slicers, and then we say the filter pane, for example, filters coming through. So what this calculate does is it evaluates in a different filter. So it means basically it makes sense when we do the calculation, but right now I want us to understand that from the DAX engine, what it does is now it takes the filter, it evaluates the filter in a different, it evaluates the measure in a different filter, apart from the one that are actually already like discussed. The filters, the active filters that comes through the visual, through from the visual slices and the filter pane. And this is very crucial for us to do it. So the first task, so this is one of the first tasks. So let's, before we even head to discuss, we would have done this, but no problem. Let's see. Calculate what percentage the total cases sold. I stopped sharing, okay? Let me rejoin, sorry about that again. Okay, I'm trying to present. let me present again. So here it is. Yeah. Are you able to see my screen, Nehemiah?
Not yet. Yes, I can see now.
Okay, perfect. All right. So it's asking. It says, yeah. This one actually will give us a smooth transition to the calculate. The screen is anchor. So it asks, the task saying calculate what percentage the total cases sold for 2021 is of the total cases sold for all years. So what it wants us to discuss is to compare the total cases sold to that of total cases sold in 2021. Okay. So this way, before we even think about the importance of calculate, we can think of a way of doing this. So the percentage. So what percentage the total cases for 2021 is of the total cases sold for all the years. So we are comparing the cases that actually were sold in 2021 alone to that of the cases that were sold for all the years, and then we want to get the percentage to that. So we are going to divide the cases sold in 2021. We divide that by the total cases sold for all the years. But now we want to see how we can present that in a visual. So the first thing that actually comes in someone's mind before all this, can I for example, let's say, can I use a shortcut? And shortcut could be for instance, I'm going to create a measure. I have the total cases, right? I have the total cases here, and that is the total cases. And I'll create another measure. Let's say I'm going to create another measure, and I'm going to copy paste the same total cases, but now I'm going to name it 2021. And honestly, before I even talk about the importance of that, I just want to show how important calculate is. So let's say total cases. I have total cases here. So we want to compare the total number of cases sold in 2021 and for all the other years. Okay, total cases, and this is the measure. So I'm going to copy, then cancel that, and I had let me create the measure here. This measure I'll try to compare and see if this will make sense. So I have total cases. So instead of having total cases, I'll say 2021 cases here, cases for 2021. For 2021. So I have the same. I have the same function. Have I stopped sharing? Am I?
Yes.
Yes.
Stable networks giving me problem, and normally it's okay all the time. So the time when actually having these discussions, it's like in ambiguous. That's the time when it should actually get start acting out. I don't know why. Okay. Okay. So I want to compare, for instance, if I use the total cases I've presented. I think it's presenting. Yeah, so what I did is I just copied the measure from the total cases into another measure, and the other measure I've just called it cases for 2021. So when I do that, I'll just save this, and then I want to compare these two measures because I've created, and then I will filter out these two measures using another filter, for example, a slicer. Then I I use from the slicer, I use the date table, and I filter out for 2021, and I see what's going to happen there. So the question is asking, I compare the total sales. I compare the total sales for I compare the total sales for 2021 and for all cases, right? So let me just uncheck all these ones. So I have the total cases here, and then I have also total cases for 2021. It's going to be the same here, but what I want to do is I want to choose a slicer. Then I try to filter out using the slicer, and I use the date table, and then I use the column for date key. So, right? Oh, year, no, date key. It should use the year because I want to filter out based on the year. So, instead of using this, I using the other. Tile. No, yeah, let me use tile, no problem. I don't have any problem. Let's just, so if I filter for 2021, you see, if I filter for 2021, it filters for both total cases. You see? So it filters for the total cases, and then it filters for cases for 2021. What I want to do is I want to have a different filter context for different measures. So if I have a measure for these total cases, this measure, and I have another measure, when I put a filter on this measure, for instance, 2021, I don't want it to actually alter the way it's doing it. If I click for 2018 or any year, both measures will change. So what I need to do, I need to calculate a different, I need to get find a different filter context for different measures in the same visual. So for different measures in the same visual. So, and that's where now calculate comes in, and calculate is very crucial. So in this case, we are going to change our DAX equation, DAX for DAX measure for cases for 2021. And now it will look like a different, now 20 cases for 2021 will be now calculate. So we're going to use calculate function. We said calculate. Now the calculate had the expression. Let me just go back there and confirm with everyone. Calculate, we have the expression, and then we have the filter. So we'll do the expression. The expression here in this case, we can use it says either you can use the expression itself or you can use measure. So if I go back again and make it clear, here it says calculate takes an expression or a measure. So in this case, simply we have a measure, and the measure here we're looking at is the total cases because we want to see total cases. So total cases. So we can write square table. Then we have total cases, and then now we do our filter. Our filter is based on date. So we are filtering these total cases, and that's what our case for 2021 will look like. So we have the date. We have the table, and then we are filtering by year, and the year is actually equal to 2021. Yeah, this is what we have been doing during the time of DAX. But now, in the case of why is it important to do this filter? Why is it important to modify the filter that was already inherently present, the active, that was coming through the visual? So now we know its importance. Its importance is why we're using the calculate function. Calculate functions are normally used to modify the filter that are already present. So already we have this now. Once we do this, now let's see what happens.
So basically, the calculate function uses the measure as and that part for expression.
Yeah. So yes, this exactly, it can use measure or expression. So in this case, yeah, both. If I wanted to make any expression, I would have actually done. I would have written the sum wine sales. You see, sum wine sales into cases sold. Right. That will give me the total cases. So the same. So if you have your measure, you can use the measure. Measure is just as simple. It's like a shortcut. In this case, rather than having to do the long expression.
Just like the CTA or the Ninin,
Yes.
MySQL.
Yes, exactly.
Okay. Thank you.
Yeah. So whenever we're referencing a measure, we use the square. We start with the square table, square bracket. So yeah, that's why what we had trying to present again. Like I've lost connection again.
But I think the smartphone microphone is more stable, and also you can monitor easily what you're doing.
microphone or
The microphone, I think the phone is now perfect. Last time when you were using the computer microphone, it was breaking, but now it's
So breaking.
stable.
Clear. Is it the microphone or was it the network?
Now because the network is affecting now the screen.
The audio.
Now
The audio.
the presentation, but for audio is very, very clear.
Okay. Great. So for the cases now, the first measure we said, now we've actually, what the calculate function, it modifies the filters that are actually inherently present in the measure. For example, right now, it just, and the format is the expression or the measure, then you do the filter. Now this is the filter. So, and the expression here we've used total cases because I would have still we could still easily write the expression using the sum, but that would actually make everything long, but simpler because we have all the measures here. It's easy to use the measure.
It's like the variable, the container for the code.
Yes, yes, exactly, like a variables. Variables. I think right now we haven't focused on variables, but when we go to Python, I think it's one of the most important things to use here. Variables. So variables. So we hopefully even in DAX, it's important to have variables because of readability and easiness. But in this case, right now, we know from OFED, whenever we have calculate, we have expression or measure, then we have the filter. It could also be many filters. Now the question has not ended. The question was asking us that we calculate what percentage. So we want to know the percentage now. The percentage now we create another measure. We call it percentage cases. So we call it 21 percentage. Let's call it that one. And then we actually use the divide expression, which is, I think, something that is easy. So here we have, let's call it 2021 percent equals, and they divide. We divide. So we have two measures, and what we are dividing is, the 2021 cases for 2021, and then we divide that by total cases, isn't it?
I think you've lost your network again.
Okay.
Are you hotspotting or are you using Wi-Fi?
I'm using Wi-Fi. Just that I'm in the room and the Wi-Fi is in the sitting room, so maybe it wants me to go there, and we might have issues with charging if I go there. Okay. Great. Presenting. Okay, so 21%. We actually dividing the cases for 2021 by the total cases. So divide is crucial. We use divide and not the slash one, because if you have any column that's actually being divided by 0, instead of returning an error, it will return 0. Okay, so that is why we're using divide instead of that. So we're going to have another column for that, another measure for that, a column. So okay, so once we have this, so we can easily drag and drop here, and once we do that, we are going to have what we were looking for, right? These are the percentage.
You've said that
cases.
you used divide instead of the slash. So does it mean that the slash can also be used there?
Yes, 100%.
Instead of that function, yes.
Yes, of course. So for the divide, what we'll do, let me just do it right now, and then see how it looks like. It works. The divide works. The only problem with the slash, the only problem with the slash is that if we have a column that actually whatever we're dividing, for instance, we're dividing this value by this value. If we have any value here 0, and it will give us an error, or it will give us an error, that column, so we'll have an issue. But when we have the divide itself, if you have any 0, we divide by anything with 0, then to give us as 0.
Okay, thank you.
Yeah. Like,
It also takes two arguments, just like the divide function itself.
yeah.
Not like for example, some values inside the parentheses, then a slash, then another value inside the parentheses, like just two values in a single parenthesis.
Yes, not two values in a single parenthesis, but let me try to do it right now, because it's like you took the two measures, then you just put a slash in between the two. Okay, so yeah, let me just try now show. Again, it has lost. I don't know why. No, actually, yeah. Try to present. I'm trying to open this measure. I don't know why it's taking all this long. It's not showing here. Until the dark circle concrete. Let me just create a new one. Call it 2020.
And then we'll go to that dark. I show you what I was trying to mean.
Yeah, exactly. Let's go there. It's like and I don't know why it's not been showing the ducks the bar here. Will be the problem.
Now, what if you try like to create a new measure?
I've tried creating a new measure. Let me just get rid of this. I tried creating a new measure, and it's not been showing the DAX editor, where I would have actually inserted the formula DAX expression. So let me just try to create another one, because normally, even whenever you click on any of these measures, it should just be displayed. It should normally do that. It's not showing. This all should show the editor here. Let me just try to create another one. So, for example, that's a new measure. Okay, let's see. See, it's not showing anything.
I think we can just proceed if it fails. You can just.
Let me try to create it in the cells, maybe somewhere else, and see if it will create. Because I'm wondering, I think there's a problem here. Not even showing again. You see, there's an issue.
Oh, I see. There's that kind of a drop down on your top right. Is it top right? Yeah. There's something that I try to click on it so that it points downward. That's drop down.
Yes, the switch, this one, right? I'm trying to do this one, right? The switch ribbons.
It's not showing.
It's not showing.
Wow.
Let me go there. Yeah, I know it will show. No, it's not. There's another issue. Okay. So because we need to create more measures, and I don't know what the problem is. It's not showing the editor at all.
And what if you try to create via the other panel, perhaps the tables tab?
Yeah, I tried doing that. I already tried doing that. So let's again, if I'm trying to do it once again. Let me try and save, and maybe save this one, close it, and then open maybe the Power BI. So this is my laptop. Yeah, I'm trying to create a measure. It's still the same. It's not showing anything. So let me just save the way it is, and then I actually open it, reopen again.
And it seems we have only few serious people. We have Nemo, Lucy, Jose, John. These are the only serious people. The rest went to sleep. And we have around 200 people.
Yeah, that is interesting.
Or are they watch on YouTube?
Maybe that's good.
For me, I like watching in real time. Watching
yeah,
on
there's
YouTube,
a lot of things you would see. Yeah, in videos, there's a lot of things you would have questions, and
yes.
like even when I was going through these DAX, you'll find that there's a lot of things you have a lot of questions, and when you just, for example, when you are not doing it in live real time with someone, then it becomes a bit challenging. Also, like even you remember we were doing some of the DAX some of the MCQs, not MCQ, the projects, and then people who are still even they watched the video, they still had questions. So because there were a lot of discussions ongoing, we were changing the DAX, and then people, so they were just, I think people were just like pressing move forward the video to see the DAX, fed down the DAX, move on. You see.
And the videos are long, like 3 hours. You just feel those hours remain, then you sleep. You know, it's not convenient. I don't know why people don't like live. But it's okay.
The videos, by the way, I think 3 hours is quite very long, but yeah, it works. Although it would be better if every day people are meeting, and then cover like the last one, the way we did. We covered in a week, and we covered like I think in 5, how many days? So you do 5 slides, 10 slides, small slides that's understood very well. Yeah, I think that also works. Yeah, but I don't think everybody can have the time to actually log in for every day, right? Yeah, but if the video is like 40 minutes long, that would be the perfect, ideal situation. If in 40 minutes you're able to do like even 4 slides, and then the other day you do 40 minutes, then 4 slides, then 4 until the week ends. Then you have like 40 minutes video. Someone can easily go, even if they miss one, they can go back and watch the video completely, just 40 minutes. And 3 hours. And some people, like, they haven't done for 1 week, so they have like 2 weeks work. Now they have to do like 6 hours watch video. So, let's just try it again. See. So we're almost done. So we will actually stop at filters, which I think is very important. We are at page 11. So we need 2 more pages, and then we can actually talk about. Right. Yeah, now it opens. It's okay. So Nehemiah was saying 21%.
I was saying, I thought I heard you saying that you can use the slash instead of the divide.
Yes.
So I was trying to ask if instead of that divide, you can add in the the is it backslash or a forward slash?
Yes, it's forward slash.
Will it
Yeah.
perform the same function,
Yes,
but
let's do
not
it.
convenient?
Yeah, no. It will give you the same results.
Mm.
The only things I want us to have this so that we can, at least we have 0.28 here, starting with 0.27. So when we click on this, I want us to do that what you just said. So we remove the divide, and then we put a slash in between, isn't it? Right?
Now, what I was saying,
Yeah.
instead of that divide function, use the forward slash. So
Yes.
it doesn't work.
No, that's what I'm doing right now. If you can see my DAX, you can see this measure. So
not like in that place. Instead of the divide, you just replace with the forward slash instead of the function.
No, that won't work. What works
Okay.
is like normal way. The normal way we do the division in class, we used to do it. So we have like the measure, then you divide it with another measure. That works. This one should give you the same result.
Yeah, I think
But
that's
if you
the
put the slash before, it won't read like that.
That's the thing that I was curious about. I thought it could work, but it's fine. I've understood. Thank you.
So it gives you the same result. The only problem is like so if we put slash here, you can see, for example, the way you just said, put slash there. So it doesn't work like that. You see?
Okay. Yeah.
Yeah. This is what we're saying, right? We put a slash in before the measure, isn't it?
Yes. I've understood. Thank you.
Great. Let's leave it at that. Okay, so the other one says so that's the importance of using a calculate function. The calculate function normally modifies the filters that are already existing in our actually in our filters in our visuals. To calculate the total cells where cases solved value is greater than 450. Hello, are you able to hear me?
Yes, I can hear you.
Sorry, yeah. So calculate the total cells where cases solved value is greater than 450. So in this case, cases solved that is greater than 450. Anyone who has an idea? The rest who are here and discuss. So we use the calculate function. So the question is asking, calculate total cells where cases solved greater than 450. So let's put cases greater than 450. So here we have calculate function. So we say the first could be the expression or a measure. So we ask total cases. So we can use a measure total cases, and then the other one is asking is another filter. So we can just read it like that. So it says where total cases where a case is solved value. So cases solved value. So we can say find stable cases solved is greater than 450. So yes, so this will be, it will actually filter for that. This will be the filter, and this is the measure that we calculate, and that gives us the measure. So that is quite straightforward. The rest also, for example, total cases in May 2021. What will happen in that case? Total cases in May 2021. If anyone who has an idea can help us there. May 2021, we'll have calculate. So cases.
Can you use the count function?
Count function.
Yeah, as in, see, total cases is just the number of cases in 2021. Or it's a sum. When you mean total cases, you mean the sum? Ama you
Total
mean
cases,
the
yes, it's a sum. We have already created that measure.
Okay.
Yeah. So what we want to get is we're using a calculate. So we were using a calculate function, and what we want to get the total cases is the measure we already have, and we want to calculate those cases in May 2021. We want to filter for May 2021. So how do you do that? So even if you do count, you said even if you do count, we've already done. We did total is a sum, not count. Total is a sum. So we got the sum of those cases, and then now we want to get the filter. We want to actually modify the filter to May 2021. So we have to use the calculate function because of that filter specifically. So in another case, in another world, you would tell me you're going to put these total cases in a for example, a visual total cases total cases. So here we already have, and now I want to filter for it. So let me just uncheck this too. I have it here. Let me just check this percentage. That, and then this, and I remain with yes. So we already have this. Yes. Is it Lauren? We already have this. So if, for example, if you wanted to actually get total case in 2021, you can do two ways. One is the way we have to calculate the function, or you come with another filter, and then that filter will only have the date table, and then it will have the year column, and then you filter for 2021. Okay, but that is actually not an ideal way of doing things. So the only way is the best way. We said if you, for example, had other measures. Now we only have one, but if you had other measures and you wanted to get the total cases for 2021 only, and you have a filter, that filter will actually affect all other visuals, all other measures in this same visual. So you want to come up with a filter context that will not have an effect on the visual. So basically, coming up with a different filter context for different measures in the same visual. Suppose I had average sales here. So I have total cases. Let me go for another cases. So next year cases, for instance. Okay. And then the same question is asking you to actually get the total cases in May 2021. So if you tell me, for instance, I'm going to use a slicer, I'll use a slicer, and then in my slicer, I tell you, like in my slicer, I'm going to have a filter, and this filter will be for the dates table, and the date table I'm going to filter the column for year. So for instance, and then this is what we're discussing. So slicer setting, and I change into time. So I have, for instance, this one. So I want to check for May 2021. I have to also filter the month, I think, not just the year. I also have to filter for the month in this slicer. So you see, I have 2021. I have to filter for May. Let me just uncheck all of them, and then I check only for May. So for instance, so when I do that, if you look, it changes both total cases and the next year cases, isn't it? Right? If I check for that,
yes.
I won't have the right answer. So what I want is a filter that will only have on my, for example, if I'm looking for next year or maybe total cases in 2021, that will only change total cases and does not change the other measure that is in the same visual. And the best way to do that is using the calculate function. And that's the reason for why we say calculate function is very important. Yeah. So yeah, now I think it's a bit clear, because calculate function is one of the most important you'll use, because it's like you use filters. You want to modify the filters that are already existing. The filters, we say there are 3. One, it could be the slider, it could be the filter pen, or it could be the filters within the visual that way. And that's like the first column that we normally actually use. The first one right now, the wine column. Right. So let me uncheck this next year. Let me have Nature 2 edit on this. So the question was asking us total cases in May. So it's straight away. So total cases in May. So I can say, okay, total cases in May. Let's put like that. Total cases May. So this will be calculate, and then the expression. My expression is total cases, and I have measure. So then my measure is going to be still total cases. And then I have the filter. The filter is what? date table, month key. Is it month or is it month? We have two, right? So we'll have two filters. So we'll have the year, 2021. Okay. And then we have also, so the best way to do this is actually having that. And then, okay, so that clear. And then the next one is dates table at the month number. At the month number, we have the month tells. We were told it is May. Okay.
So this DAX thing, just like the SQL, it doesn't consider the indentation issue.
No, it does not. This one it doesn't.
Okay.
Like SQL does, I think, right?
Yes.
The indentation, the white spaces. The reason why I'm doing this is because just to get the clarity and show that these are two different filters. It's easy to understand when it's when you're using instead of 119. Yeah. Okay. So it will filter for that now for only May. And what is it asking us to do here? Yeah, I think that's fine. All right. So yeah, total cases, May. Yep. So now if I add another filter and I filter for that, it will only change this instead of this, instead of both of them. If I add another slicer and then I change for, I do total cases May, and then I do those kind of like, I start changing those filter in the slicer filter to only change for this column and change for. So that's the importance of calculating. Let's check the rest. I want someone to give me what this one look like. Total cases for Abel in Argentina. Total cases for Abel in Argentina. Total cases for Abel in Argentina. So this is actually number. Abel is a salesperson. Argentina is the region. So I want to get the number of cases he sold, wines he sold in Argentina, specifically in Argentina. So let's get a measure. Someone to give me that measure. We're still on calculate.
Maybe you repeat the question.
Question, right? Yeah. Okay.
So there are two variables. One is Argentina, and then maybe you repeat. Then I'll try to see.
Okay. I'm trying to rejoin it because I can see it has logged me off completely. Yeah, it says for the question total cases for Abel, so that's the salesperson in Argentina. So we want to know the total number of sales he's made. This guy has made in the region Argentina. So how many customers have actually bought the wines or residing in Argentina, and the person who has made the sales is Abel. Those are the things we should be checking. Am I presenting?
No, I can't see.
All right. So it says total cases for Abel in Argentina. Total cases. So we did total cases in May. So we want to calculate the total cases for Abel in Argentina. So Abel is a salesperson. So we want to see the amount of sales he's made in Argentina on his own. So so it will be calculated. So what will be the DAX? Nehemiah, what do you think?
calculate, and then
So we're still on total cells, right? So our expression will still be the measure, and that measure will be total cells. Nakubaliana hiyo iko sawa, isn't it? So we will have our total cells, total cases in that. Now let's do the filter. So the filter will be what? So the filter will be Abel. Let's start with Abel. So it has to be Abel because we have different salespeople. So we have salespeople table, and then we have salesperson, isn't it? So salespeople, salesperson should be equal to Abel, right?
Yes.
Yeah.
It
and
is
then
in which table?
The table is salespeople. So we started with salespeople, and the column is salesperson, feeding Abel, and the second filter will be Argentina, right? So Argentina is another table, is the region table. So we'll say region, and then we have regions. So in that table we had regions as the one that actually listed the countries. So we can say regions, region. So regions is the table, region is the column where we have, and then we have Argentina.
I see someone has raised their hand.
Yes.
John, I think John, can go ahead.
Thomas, I have a question.
Okay.
So why haven't you used related in the salespeople, but in the other measures, when you're creating the other measures, you're using related?
Yes, that is true. But now the reason why I'm avoiding related is because this is a filter. Related will give me an expression, right? So calculate supports an expression and then a filter. So let's try and do what you're saying. That's a good question. Let's try. So let me just copy this too. So if I do this and then I put related function, and then the table I choose is here I choose the related. So the first one will be cells. It says related, now column name. Column name is, no, this won't work. Do you know the reason why this won't work? Yeah, if you put related inside,
you cannot see the screen. You stop sharing.
Okay, sorry. So let me just.
So, in other words, you are saying that you use related, for instance, when you are creating measures, or maybe those are calculated columns, and then now the calculated, when you use the calculate formula, is when you want to do some filter on measures.
Yes, exactly on measures. So it means on measures already, every measure is already, as we said, is a filter specific. So whenever you create a measure, that measure will be evaluated based on filter. So the filtering, and we said the three different types of the filtering, right?
Yes.
So already they have inherent filters. Now, but you don't want to use those inherent filters. You want to use another filter. You want to modify those filters is when you use the calculate. And the calculate way is the calculate has the syntax is it has the evaluate, so the function and the expression or the measure and the filter. So in this case, when we use related, we cannot filter using related, because if we do that, if you can see, if I do related here, you can easily see related will have a column name, related table. Let's say related table. That makes sense. Not related table, and then I do salespeople. You see, even if I do related table, it will only filter for related table, and it will filter for everything for all the people who are in this salespeople table dimension. So yeah, we cannot use related in this case. So we have to use a filter, and the filter will either be expression or it will be a filter. So we'll actually look at the last case, which is where we are going to be putting another filter in the filter. So remember we have two arguments. The first argument is the measure. The second argument is the filter. So this filter argument, we can replace that either with expression or with another filter. We will see where we need to replace an expression or another filter Edwards in the next chapter. So there's a person who was asking, Tom, I think it was Tom, right? Was it Tom or John? Someone was asking a question. He said, why can't we use related? If we use related tables, related will not give us a filter. We won't be able to filter with salespeople. That's why we're using the salespeople table and then salesperson. Is that okay?
Yes, I've understood. Thank you.
No problem. Bill. The next is the second was regions. Then arguments of regions, region, and then this is Argentina. Okay. Right, great. So let's filter for that. So this will display the total cases he sold in the region, Abel sold in the region, Argentina. So the other one's asking total cases for 2020 or 2021. So this uses OR. So it's the same. We will use let's do this, but G is where actually I want us to put more effort on. So good. So we have total cases for 2020 or 2021. So someone to give me how that DAX will look like. They have an idea. Cases for 2020 or 2021, which equals to we're still on calculate, and then total cases we are still on total cases. Again, total cases, and now the filter is what? So what will be the filter? Date table, and then we have date table, and then we have year, isn't it?
Yes.
So but now we asked or remember we asked or. What does that mean? So do I include if, or we just actually go ahead and use the filter, the other filter? Let's say this filter 1, 2020, and then filter 2 says date table. Date table. Year was 2021. So this will produce what I think is this will produce. We're using OR. So if we're using OR, we have to use the double pipe here, isn't it? Are we together?
Yes, we are.
Yep, very true. Yep. So that's how this will give us now all that. So one thing we have to be also another be keen on is like we don't have a comma in between here. Our main reason is because these two are not different arguments; they are the same arguments. So we are using OR because we're considering these two filters out of them. That's why we don't have a comma. So if we had another one, that's why we would. And this is the last one. So sometimes people might confuse why sometimes you're using comma, sometimes you're not using a comma. Comma different. It actually distinguishes two arguments. And if you are within the same, looking within the same condition, so you don't have to use the comma. So one thing that I'll actually try to, which is very complex, but I'll try to explain. I'm trying to log in here. I'll try to explain in a very brief and very concise way. Is the next question, which actually asks us to calculate sales for red wine and French wine. So it's loading. Okay. So this is a very, very, very interesting concept that will actually take us to the next subsequent section. All right. So our next question says, find total sales for red wines or French wines using the type and wine country columns in the wines table, respectively, and use this to analyze salesperson's performance of these wines. Very interesting. So what it wants us to do is it wants us to actually, and we are going to do the total sales for red wines or French wines. So normal way you would want us to do here will be, let's actually create that measure. So you see how many measures we've created here. So having a measures table is way easier than having all this scattered in another table. Yeah. So we have the question is asking us. So say this is sales for red or French. So French wine. This means that red is the type wine, red or white, and French is the country of origin, where the wine has been actually sourced for. So in this case, normally we would say calculate the same way we have been doing calculate, and the expression is still total sales, isn't it? Total sales is still our now our filter. You would tell me would be the question is asking. If I go back to the question without having to move very fast, find the total sales for red wines or French wines using the type and the wine country columns in the wines table. So we are using the wines table, isn't it? So we are using wines. So wines. We are using wines type is equal to red, isn't it? And then we have or, and then this gives us wines. So it says, what other column? Wine country.
Imran.
Yes.
We are calculating the total sales, not cases.
Thank you. Yeah. Total sales. Okay. Yeah. Total sales. This is okay. Okay. You asked me why we're using total cases here.
Yeah. Why did you put total cases?
Why? Because what we're selling are the cases, right?
Okay.
Isn't it? Yeah. Sorry. It's total sales, not total cases.
Cases ni chupa.
Yeah. Let me repeat this question. It says sales, total sales. Thank you so much. Not total cases. Thank you so much. Total sales. Total sales. Yeah. I was wondering. It should be total sales. Thanks for pointing out that.
Okay.
Yeah. So that total sales. Wine country equals to what? Is wine country? Yeah. Wine country equals to French, right? So yeah, I hope those are the things we asked. Type, wine country columns, French, and the question was asking French wines. Now we're going to analyze the salesperson's performance on this. So now what could be the more wrong with this DAX? Let's try to analyze this. So it will give you the correct. The DAX correct according to this DAX. This Power BI version. It says this is correct. But normally, what happens? This version is, I think, 2023. Any DAX version that came prior to 2021, prior to 2020, is it 2019 or 2021? 2019 would never allow you to carry out this kind of calculation. Why? Because this calculation, right, normally, if you look at this might actually, what happened, this expression doesn't respond correctly to the specific filter selection. Why? Because if you look at the wines, if you look at the table we're using here, we're using wines table, right? and the columns you are referencing is the type and the wine country. So what happens is when the filter is actually propagated, it will not actually give you the right specific filter selection, mainly because we have referenced two columns from the same table. So whenever you're doing that, you make sure that you don't use a calculate the way it is right now. I'm trying to present again. So I don't know if I'm making sense. But whenever you're doing a filtering in the calculate and you reference when the filter includes, for example, more than one column for the same table, and when the filter also includes an expression, those two times you cannot actually use the calculate, and it will give you the right, because it will show the DAX is okay. It will give you a value. Let's try now check that whatever value it's going to give us. I'm trying to log in again. Let's see the value it will show us, and then we'll compare that value and we're going to write the right DAX. So these are some of the reasons why I think it was good to have a recap of DAX, and I feel it's very important, because initially we never personally I never had an idea of how this could affect our results when we were actually making analysis. So let's do the analysis. I'm going to do the analysis right now. So we have that DAX. That's fine. So let me just create another table here that I want to see. And this now I want to analyze the salespeople, isn't it? Because that's the question is asking is salesperson's performance. So we see how they're going to perform. Salesperson. And then we actually put the measure we just created, and that measures what? Sales for sales for red. Okay. So yeah, so if you look at this measure, click on this measure, and then so for this measure, I have these values. You can just make sure that we have them somewhere. So we have 226,180 in total. These were the sales for red or French wines made by these salespeople. So Abel made 36,854 total sales for either red or French. That's what according to CX right now giving us. But initially, what happens? What we need to be very careful here is that the filter propagation is not done correctly. So the expression here, this expression, does not respond correctly to specific filter selection we've selected. Mainly why? The main reason is because we have referenced two columns in the same table. So when you reference two columns in the same table, it means initially the Power BI actually was prior to 2019. That's what I think. Prior to 2019, it will never allow you to carry out this kind of calculations, measures. Why? Because it will tell you cannot actually do and you have to specify what you want to do in between these two columns, because the two columns are from the same. And so so this is where now filter function comes in. It's very crucial. So right now, if someone would be like, I'm correct, I have the values I'm correct, but now this is not the correct values. The correct values we'll just create right now. So we have to create a filter. We have to use a filter function. This is why our filter function comes in. Filter function comes in. So, and filter functions are normally called table functions. So table functions are functions that normally create a table, and this table normally they are virtual tables. So table functions create expressions. Table functions create table expressions and can be used for mainly two purposes. One is to generate additional tables in your data model using new table pattern. This is referred to as calculated tables. Normally, that's everyone understands this. The second is to generate in-memory virtual tables as part of the evaluation of measures. So table functions return virtual values. They normally return virtual tables. So those virtual tables is not what you want to use. So what does that mean? It means that you have to nest that in a scalar function, like a calculate, like any count rows, like any other. But now filters normally, let me just log in. Filters normally return virtual tables. They create virtual tables in memory. So in this case right now, we can see the need for filter. Why? Because we need to create a table, a virtual table, and that filter function will create that table. It will iterate. For example, let me just go back here and then see. So let's go back to this. Yeah. So in this case, for instance, we need to actually filter out the rows we want to evaluate instead of the columns. So for us to do that, we need to create a virtual table. And the function that will allow the virtual table, we said, is filter function. And filter function is a table function. So the virtual tables are typically subsets of rows or subsets of columns of the original table, but they can expand the number of rows in case of the all function. We'll come back all function. All function is a function they normally call, it is the sheep. It's the what do you call it? It's kind of they call it an evil because you think it's very easy but can cheat you very much, the all function. But we'll have a look at hopefully some other time. Time allowance. Today I don't think we will be able to. So an example of the virtual table table functions, we checked also types of functions initially. From the first pages, we have filter, we have values, we have previous month, for instance, which will actually give us a string, and then we have all. So in that regard, let's move forward and then see the syntax. So the filter function returns a table that is a subset of another table and has the following syntax. So filter does filter, then you choose the table, and then you actually insert the filter. So you see, it's a filter, table, filter. So when you have a look at this, someone might easily get confused. But when you understand this, what filter does in the memory, what filter does is normally it creates a virtual table. That table will have, for example, it will have a filter. So this filter is what the rows will be. So it will the filter function iterates for example, that a table in memory and filters any rows where you've actually defined your condition. For instance, if you say type is equals to red, in this case we say wine country is equals to French, and then what happens? The filter generates in memory virtual table containing this row specifically. So, but now the issue is the filters, they return only virtual tables, and those virtual tables are within. We don't see it. So those within in the memory, they have to be nested. When you nest it in a scalar function, is when you can actually evaluate your actually measure. So we'll have a look at that right now. I think I've also lost correction again. So it's a very interesting concept. So right now we have seen that whenever we are actually checking for, right now we are doing cells for red or French, and we referenced columns from the same table. We cannot use calculate on its own. So we need to introduce filter inside calculate function. So that we create a virtual table that filters for the rows that contain, for example, the red type is equals to red, and then the wine country equals to French. And then once we do that, then in this case, let me just go back to that. So this is the value it has returned. Going on. So let me create another measure, and then we compare the two. That's what I want to do. Let me create another measure. Now I call it cells for French, or cells for red or French number 2, so it can differentiate the two. I've used very long names, that's why it's a bit kind of difficult finding a measure here. So sometimes you can use a shorter name, but it shouldn't be diverging that much from what the measure is talking about. I'll just write cells for red or French. So this is equal to calculate. Then we have the same whatever we had. So we're talking about measure, and the measure is total cells. And then now, in this case right now, we want to place the filter inside the calculate. So which means that we are going to have a filter, and the filter has, remember the filter has a syntax, and the syntax of the filter is filter, then we have the table, then we had filter again. So filter, then we name the table, and the table here we are referencing is the wines table. And now the filter is, we say it's wines type is equal to red, isn't it? Or, isn't it? Or wines, we have wines country is equal to red. Yeah. Does it make sense? Does it make sense?
Ebu repeat. Ebu kindly repeat.
Let me repeat. Okay. Initially, what do we have? What do we have? Let me just put this one as 2, so it doesn't confuse us. French. So initially, the first we had cells for French. Let me go to that cells for French. Loading. Cells for French had calculate. We said calculate total cells, and then we never had any filter, but we had wines type, and then we had wines type equals to red, and then we had wine country equals to French. So that was the filter. The normal we were using throughout the calculate function. We said the calculate function takes an expression or a measure, then it has a filter, isn't it? So it had a filter, and our filter was, we said it was wines type equals to red. I want to get that point. Where is that total cases for total case total cell? Yeah. Why can't I see? Okay, I name it as total cell. No problem. Let me just use that. Open it here. Yeah. So initially, if you remember, we were still using our calculate function. We did the same we did. So what we're trying to get here is the question is asking us to actually, where is it? Oh, it. Yeah. The question was asking us find total cells for red wines or French wines using type and wine country columns in the wine table. Okay. So what we did is we calculated. We said calculate total cells was the measure. Wines type is equals to red, or wines country is equals to French. So there's nothing wrong with this DAX. This DAX seems like to be okay. And now the problem comes in when the filter propagation is happening. The DAX engine might actually give you the wrong. This expression will not be actually the correct specific. It doesn't actually respond to the correct filters. Why does it not? Because if you look at this, the tables, we're using the wines table, and we're using different. So if you are actually filtering, different columns from the same table, you have to specify you have to have another filter function in your filter. I don't know if you're making sense. Yes.
Abdi, before you continue, so you want to say that if we are using, like if you're in the same table, we are using different columns, you use filter.
Yes.
So
why?
What if you are using like different like 2 tables? You'll still use filter, or you'll use calculate only?
You can use the normal calculate.
Oh, okay.
Yeah, the only 2 times when you have to use filter within the calculate. So 2 times. One is when you are actually using referencing 2 columns in the same table as the first one. The second one is when the filter includes an expression. So when this filter includes an expression, we'll have a look at that. An expression, for instance, you want to calculate. We'll say an example. When this filter includes an expression, then you have to specify, because the DAX itself will not propagate the filter very well. You want to actually first of all filter and filter iterate the wine table. In this case, for example, you want to iterate the wine table in the memory and then you filter so that you can filter, because within the filter we have other filters, isn't it? So filter has filter itself, because if you go back to that total cells, let's see, I'm going to show how we've actually done that. Total cells, yeah, for French, right? So this one, total cells, we have filter. This filter itself has a filter within. So this is the filter. This part is the filter. Okay, this part is the filter. So when the filter function does is it iterates the wine table. This is the table that it will iterate, and then in the memory, and then it filters for any rows where type is equals to red and the wine country is equals to French. When it does that, that's actually filtered. Then it creates a virtual table that contains only the rows for either red or French. Are we together? So where the test is true. So if that test is true, then the virtual table now is generated by filter now. Exactly. By filter, it's used to filter. So now from there, that table will be filtered, and then calculation happens now. Then we are going to have some of that. So cells from that. So it's simple that. So the main thing here, the main trickiness is whenever you're referencing two columns inside a table, or you have a filter in your calculate function. If you have a filter that includes an expression, those two times you have to specify. You have to actually insert filter, and that's why we say filter is they call it is a table constructor, or probably what we said here is a calculate function. We call it a table function or table creator, something like that. So it's a table function. So it creates that virtual table, not just filters. So it's also values. There's time we use values. There's also previous month, and it's all. So that's the importance. And if we had time or other sessions, we would see when we need to use values, previous month, and all. But in this case, I don't think we'll have time. So let's look at cases where we ask, for example. So we said filter. So first, filter can be used to reduce rows. Very true. Sometimes when you have a lot of rows, you can use filters to reduce the number of rows. Okay. So in this case, task you are told to calculate the number of high volume cells, where high volume is any transaction where cases sold value is greater than 450. Yeah. So for instance, when you have a let's do this DAX, you create this DAX, and then we explain. I wanted to compare before this. I wanted to compare these values, by the way. So for this table, we had this before we moved that. Sorry, I forgot. I wanted to compare which one is correct. For example, here we say the first one. This table has this. So if this is how it looks. If I choose the other one, how will it look like? So if I choose the other one, I create total cells. Total cells. That's why I use cells. So let me uncheck this, and then I use cells. 180. So giving me the same in this case. No, it's not the same, different. This full case for 2021. Now it's giving me the same, but it's not supposed to give me the same. It's supposed to be different. Why? Because most likely this right now maybe it's correct because of by default, or probably because we have the latest version. But normally all books and all DAX, even if you go to Windows, that's what they will tell you. Even if you look for other DAX, or whenever we are using calculate, and then we're referencing two columns, we have to specify the filter two columns from the same table, you have to specify the filter, or when you're using expression. That's the correct way of actually always doing it. And in this case, if it has given us the right answer, but maybe it could be because there's a more advanced version we're using right here, but or by fluke, but that's not how it's supposed to normally. Those are two exceptional conditions written by all books, as well as also explained by Microsoft Windows. Good. So let's proceed. So this one was asking us to calculate the number of high volume cells, where high volume is any transaction where the cases sold value is greater than 450. So let's create a DAX for that. Number of high cases volume. So this one is actually we're trying to actually calculate the number of high volume cases. So here we won't use any calculate. It's just using the count rows. Why? Because number of high volume, number of cases, number of high volume cases. This will be high volume cases. We're just trying to count the numbers, high volume cases. So this is going to be count rows. So I don't want anyone to get confused here, because in this case the question was asking different. So we are trying to see how when filters can be used to reduce rows, isn't it? So that's what they're doing basically. Count rows with the number of high cases. Count rows in this case now. Count rows. Then we use filter. We use filter, so we use the wine cells. So filters normally they have wine cells, comma, and then the function, the filter, so which is wine cells. Cases is cases sold. Wine cells cases sold is greater than 450. So this totally makes sense to me, mainly because we are asked to count the number of rows. So if you were just to calculate, for example, we were told count the number of high volume cases, I would just use the count rows, and then I count rows. Then I just use this side that represents the number of high volume. But if I want to reduce the number of rows, and I want to actually the filter to be very quick, then I can filter using now filter wines filter, isn't it? So I can use the filter. So the filter will now actually specify only that instead of actually counting all the rows. But now it's actually specified, so that's what basically filter does. Yeah, this is, I think, this is straightforward to understand. It wasn't that difficult. All right, so we are doing the last measure. Perfect. So last measure. So find the last measure is filters can be used. So in this case, not a filter can be used as filter argument of file. So we've checked this. We've done this. We've done that cases where we have the red cells for red, or French where we actually used a filter. We used a filter as the filter argument of calculate. So the calculate had a filter argument. So we inserted filters. That's how we got the right answer. We said because the columns where we were sourcing for that was actually in the same table. So now in this case we are going to check for the expression. So it says find the number of cells, i.e. the number of rows in the wine cells table. We have checked this for high profit wines. So what is high profit wines? High profit wines are wines that have, or wines where wines have a price that is 3 times the cost price. If we check our wine table had price at which we bought the wine. And then let me just go there. Let's cancel this. Then I go to the wine table. Actually, see, we've actually gone through this. Initially, the wine table had. I'll just use one of these measures. If we go to wine table, our wine table has a cost price, and it also has the the price at which we actually sold, so per case, and then we had the cost price, the price that actually it costed when we were buying. It has logged me out again. Am I audible? And am I with you guys?
Yes, you are. That the
Sorry.
screen. The screen
Yeah.
is.
Yeah, this is the last one. So the rest I'll share some writings, and then people can follow up. If there's any question, I'll actually be happy to answer. If there's anyone who wants me to carry out a session with them, I'm open with that. So let's actually finish with this. So let me go to Wines table. So Wines table, am I presenting?
It's not visible yet.
Right. Okay. So here we have the price per case and the cost price. So the question here is asking high profit wines where wines have a price that is 3 times the cost. So when we sell this price, for example, we bought at 25 and we sell 3 times this value, for example, like Bordeaux, like 3 times of this, isn't it? So if we sell, those are high profit wines. So we need to get an expression for that. And right now, when we create an expression for that and we still on calculate, is always good to actually, we said 2 conditions. One, the first condition was this one, where we replace, where we use filters as filters in the argument of calculate function. And the second one is now where we're actually discussing when we have an expression. Those are the times when we say calculate functions are for exceptions. We have to use filter and specify filters. 2 conditions. One, the first is when we have 2 columns, when we are referencing 2 columns from the same table, or when the filter in the calculate function contains an expression. In this case right now, we're looking for the number of cells, which is we calculate from calculate and number of cells measure. That's fine. For high profit wines, and for high profit wines, we are defining an expression. So that filter will contain now an expression, and the expression would be where we have the wines table. We're going to reference the wines table. We are going to say the wines table. The price per case is 3 times the cost price. So let's do that. It makes sense. It's not that challenging. So let's go to measure. And then we write number of high profit wines. So this will be equal to now calculate, isn't it? So the first expression is cells, isn't it? So we are going to number of cells. So we are using a measure, number of cells. A measure, okay. Number of, do we have the number of cells? The total number of cells, I think. Total cell. Okay. Do we have number of cells? A good question. Yeah, it's the same. Total cells. And then you're going to know, we say here we have an expression. So if we have an expression, remember we said we're going to use a filter, and then the filter itself, and we're filtering for wines dimension, and then we have wines dimension. We have cost per price is 3 times. Cost per price is greater than or equal to that. The question was asking something like the price is 3 times, so it could be 3 times or more. So we can just put probably is 3 times or more, because that equal, you can even use equal, no problem. But initially it means the best way to explain is that if there's another one that is even greater than 3 times, it's 4 times, 5 times, then that's more even high profit. So you can just say greater than or equal to. Then we have the same table wines. Then we have cost price greater than 3 times. So cost price times 3. So we are multiplying this by 3. Right. So initially if this filter, at the filter within the calculate was not an expression, we would just use this expression, wines, price per case, greater than or equal to wines cost. But this is also another, remember, we are actually doing an expression, and when we do an expression, we have to introduce wines. We have to introduce filter, and the filter syntax is table, then the filter. This is the filter. So it's perfectly makes sense. That's how we do the filter, and that's the need for filter. So whenever you hear filter or you see filter somewhere, whenever you're doing a DAX, or whenever you see a DAX somewhere, just know that filter was introduced as a result of these two conditions. All right, and most likely that filter could either be used in three. Let's say three. One is these two conditions. One, the first one is if the filter includes more than, for example, if the filter within the calculate function includes more than one column from the same table. The other one is if the filter within the calculate function includes an expression. Those are the two. And in a case where it's not a calculate function, you see filter, just know that it is used to reduce the number of rows. So those are the three. I think it is clear once you've seen that, and then it takes a bit of practice, and then the more you do, the more it becomes easier. DAX, you can never cover everything at once, you can never understand everything at once. So the main thing was to understand how the DAX engine calculates and how it populates the filters, and that also the filter context, the iterate, we did iterators with the filter context, we also did the table context. Those are the main things for now. I'll also share this PPT, so for those who wants to follow up and do those tasks, and they have the data, they have the Power BI, I think it will be helpful for people to actually proceed and try something within their limits. So yeah, so we've covered Scala functions. We've seen these functions that return this return. So we have seen all these are some count rows, some x are iterators, aggregators. Sorry, they called aggregators, x aggregators. Then you have the calculate function. We say table function. These functions, they create virtual tables. We have seen right now what it does. An example of this is the filter we've done. We've done that in the values previous one. All I would love us to do all, which is I think very important, but we can actually schedule that for another day. And then we also have the calculate modifiers. This one, the cross filters, these are very important as well. Now this one, what they normally do is when you, in the first case where we saw that filter propagation, and you want to compare two, you don't have to create table functions. You can easily use cross filters or use a relationship. Cross filters are the ones that are mostly used. All right, so we can stop at that. You can stop sharing if you're recording, Nehemiah, and then we can discuss everything.